and then put it into the Oculus Quest 2. So this is just some is sort of like a progress pic. Basically, you can see the line running through the aorta, and that's the line in which the camera follows through. The second VR experience, you can see there's two channels, one being the true lumen and one being the that come off, just so that anyone that was actually using it can sort of identify where they are within the aorta, because it's quite tricky once you're actually in the VR experience to identify the branches. So in terms of further work, so there are a lot of hurdles that were sort of encountered as we went through creating this project. Basically, a lot of software issues, things that the software couldn't handle or things that just hadn't been done before, so we had to sort of overcome those and create as we went, which is why it's called research, I guess. So some of the further development that could be carried on would be to improve the user interface. At the moment, it's quite primitive, it's very basic, but it could become something that could be really user-friendly and really intuitive, including functions such as screenshots, which would be a really awesome thing for people that perform or assess these pathologies to be able to take and then save for later on. Including more functions, so different types of measurements or different kinds of movements where they could maybe potentially click and move forward to that point in the aorta. And then obviously looking at the integration into the clinical setting. For something to be used in the clinical setting, it needs to be pretty much press a button and then this happens and then they can use it. Obviously at this point, an 80-minute process isn't something that surgeons are going to sit down and have the time to do. So being able to make this more intuitive and more seamless in the clinical environment would be a big goal. And obviously what we originally intended was to show this to some vascular surgeons and get their feedback on, is this something that could be worth further performing work on, and is it useful in the clinical environment? However, we had the COVID lockdown on the week it was meant to go ahead, so that unfortunately was cancelled. However, all the ethics approval is there, it's all, in reality it's really good to go ahead, but we just have to wait until the time is right. So I just wanted to have some acknowledgements. So this project was industry funded by Medtronic, so just a thank you to them for providing the funding for this project. A thank you to the Hive for having this opportunity available. And a big thank you to my supervisors, Professor Zonghua Sung and Shirley Jansen, for offering their expertise and giving me the ability to perform this project with all the knowledge and the software that I need for that, so thank you. And also a big thank you to Carly Tillett. She offered heaps of technical support. She's a software genius, so thank you to her as well. Any questions? Thank you.
Any questions from the audience? Up in the back, sorry, what's your name?
Alex. So between the onset of an aortic dissection and the development of the false lumen, you said that it's possible for the aorta to rupture, and that's caused internal bleeding. How long do patients have between that initial development of dissection to the consequences that might follow from it?
And we should repeat the question. So it's from the condition developing, how long is it likely to be until it ruptures?
So type A and type B dissections are quite different. Type A is a medical emergency, so if a patient experiences this, they need to get medical treatment urgently. It's normally surgical interventions provided pretty much straight away. Type B aortic dissection, there can be a few different sort of types in a way. It can be like a chronic condition or an acute condition. So if in the chance that the patient has the acute condition, medical intervention, whether that be medical management using medication and so forth, or surgery needs to be done, that will be treated to quickly. Or if it's a chronic situation, that's sort of where the controversy comes in. What is the point at which this patient becomes a surgical candidate, or do we leave it until it becomes a problem? So that's hopefully where this sort of visualization might be able to help to make those more informed decisions. Yeah.
Very good. Question in the back?
Yeah, so with the 3D slice, you said you used one of the add-ons from the kind of extension marketplace.
Yeah.
Was that a pre-trained model that helped with the dissection, with the segmentation, or were you just using kind of like Hounsfield thresholding?
Yeah, so with, are you talking about on 3D Slicer? Yeah, so 3D Slicer, essentially we used this add-on which is called the VMTK add-on. And basically it gives you more tools available, so you can perform like a local threshold and be able to get a better segmentation than just using the standard threshold tool which is on 3D Slicer. So that was really helpful, because when we originally tried without the add-on we weren't getting the results we needed, because the like the housing field units were too similar to the soft tissue ones. So yeah.
And do you have any kind of plans to overlay it back onto the kind of underlying dicot file as well?
Yeah, so that is a potential possibility. We haven't obviously got to that point yet, but yeah, that is something that could be done for sure.
Carly was busily nodding down the back.
Yeah, Carly's very excited. Yes.
I think there was a question down here. Tim Pittman.
Does it require you to take more CT scans than you normally would? In other words, does it take down upstream? Does it require a change to business in order to generate these 3D models?
So no, so the CT data sets we use were a CTA data set, which is the standard sort of procedure that would be performed if somebody was querying this sort of pathology. So we just used that data. There was no extra data that was needed to be given, which is good, because obviously we're not going to irradiate someone more to be able to achieve, you know, this sort of thing when they could do it using the CT. But no, this data can be taken straight from the CT slices. Yes.
Yep, please.
Yeah.
Just an add-on to that question.
Yeah.
What would then be the biggest challenge to apply it in a clinical setting? I mean, you mentioned
Yeah.
volume, but perhaps there's something.
Yeah, so there's a couple of clinical issues that could be, or questions that could be raised. One being, who would perform this? So in terms of like segmentation and this sort of thing, it normally falls onto like either the radiographer doing the CT scan or perform like some kind of reconstructions, or the radiologist can perform it. But in this case it would be, you know, who's going to perform it. Obviously it takes time. In an ideal world it would be a click of a button, but that's not realistic at this point. So yeah, it all kind of depends on who's going to perform this and who's got the time to perform it. Yeah.
Okay, any other questions? Okay, so I might just add that Chloe's presentation, or the visualisations from Chloe's work, and all the other presenters from this session will be on demonstration during the demonstration session. On the cylinder we've already got Cheryl's one of her 360 stills, and on the dome we've actually got a visualisation of a CT scan of a fossil, so not Chloe's data set, and I think Chloe's data set will also be showing on the hologram table over there, which is the one with the blue glow.
Yes.
So thank you very much, Chloe.
Thank you.
That was great.
Thank you, everyone.
I'll just grab the microphone.
Oh, yeah.
Thank you. All right, so let's just move on from there. And if I can check with Daniel how the this. Oh, fantastic! Yeah, we had to restart the stream, so Pon Pot will be able to be heard now. All right, so actually I should mention that Chloe mentioned it as well, but her primary supervisor was recently minted John Curtin Distinguished Professor, Zhonghua's son, so thank you for supervising. Were any of the other supervisors from that team here? Not at the moment? Okay. So our next presenter is Pon Pot. Now I've been rehearsing this, so trying to get his last name right. Jat Nilafand.
Jat Nilafand.
Okay, nearly. I think I'm missing a syllable there. And his supervisors, Rima Cachetta over here, and Lisa T. And Pon Pot is looking at the effect of drugs on pupil and ECG of the heart, and has been doing a lot of VR development in Unity on this particular project. And Pon Pot also had his graduation last night, so big Big congratulations for him. Who has been doing a Bachelor of Science in, now let me get this right, specialising in industrial optimisation and data science. Okay, so over to you. Thank you.
Thank you. Good morning, everyone. My name is Curtin HIVE, and the topic of my project is I hear your rhythms with the drug effect and on the pupils and ECG. So the rationale for a virtual model. So at first, we need to visualize the effects of drugs to enhance the understanding of the complex concepts. Because I have experienced this situation already during this project, the information I obtained about the effect of each drug are from my supervisors and the Australian Medicine's handbook by the AMH or the Australia Medicine's handbook. It's it doesn't show how the drugs affect the patient, but just telling the information what will happen when using some drugs. And so that made me a bit confused when I created this virtual model. And Australia experiments practice in the undergrad, such as physiology and pharmacology teachings are being discontinued due to the ethical problems about the usage of the animals' organs as well as their cost. And recently, people can access the internet very easily. Creating a platform for visualization is very helpful for learning. People can use the platform through internet for study. And furthermore, because of the current situation, all courses are moved into online course and not face-to-face. So this can cause the quality of teaching, and students are not able to interact with the activities in the classroom due to the social distancing rule. So to address this issue, we developed a virtual tool for observing the effect of drugs. And so in this project there will be 3 modes of the pupils to visualize effect of light, phenolphthalein, and adrenaline. And for the adrenaline, we have to inject this drug with a syringe, so we also include the human model to show the processes as well. And some drugs can affect the heart rate and the blood pressure of the patient, so we also include the ECG monitor. So for this past 10 weeks, this is my methodology. So at first I study about the background and gather some requirements. After that, being familiar with Unity and Blender software. Blender software is the software that we use to create 3D models. So after I get the 3D models, I import the models into the Unity and then create the animations and the platform for user. Then I refining the models and the materials. After that, just create a setting to reflect the hospital environments because we would like to mimic the hospital atmosphere and the experiment. Then after that, I just let users test the prototype and fix the get some feedback and fix the debugs. So here are the pupil modes. So the size of the human adult eyeball is approximately 24.2 millimeters and times with 23.7 millimeters. So the most left picture is the pupils when it is in the normal mode. And the middle one is the constriction mode, which you can see that the pupils getting smaller. And the dilation mode is when your pupils get bigger. So how the different drugs affect the pupils of the humans. So in this project we use we visualize only 2 drugs and 1 material which is light. So the first one is phenolphthalein, which is a eye drop. The effect on the eye is that the pupils will get constriction, and the effect on heart is actually the heart rate will be decreased, but we ignore this one because it rarely occurs because that's a single drop used. it should not like achieve this one. And the second one is the adrenaline by injection. So the effect on the eyes will be like the pupil will get dilated, and the effect on the heart rate will increase, and the increased force of a contraction as well. And the light, the effect on the eye, the pupil will be like constrict. Even though like you shine the light onto one side of the eyes, like if in our visualization we let the patients be like have a good health, so both of the patients pupils will like get constriction at the same time. So here's the animation of the eye dropper with the phylocaphrin. So you can hear the sound of the heart rate, and like when we press the button, the eye stopper will like come over and give eye drops on the eyes, and the pupil will be constrict. And after a while, the pupils will get to the normal rate, a normal mode. And here's another side of another view of the animation to see the pupils closer. So as you can see that when the eyes drop, like get on each side, the pupils will get constrict immediately. So here's the animation of the blood pressure tracings before the injections. So when you press the blood pressure buttons, you can hear the sound of the blood pressure cuff. And on the left top corner, like you can see the ECG monitor. So after like waiting for the blood pressure to test, after the sounds, the blood pressure will appear just for a while, and then it's gone. So here's the animation of adrenaline injection with the syringe. So when we press the button, the syringe just come and like inject, and the heart rate is increasing. And after that, we try to have a blood pressure test. So you can see the graph there, the graph like getting closer because the heart rate is increasing. And here's the blood pressure like after the injection. And after a couple of seconds, the heart rate will be decreasing, and the graph will be like getting apart and not close to each other according to the heart rate. So here's another view of the injection. So the eyes will get dilation when we inject the adrenaline into the body. And like we try to like test the blood pressure again, but actually for this one, the eyes, the pupils should be dilated like for a while, like not like this, but there is the issue that we will develop it like in the future. And here is the animation of when we press the light button, the torch will like come in front of the eyes and shine the light. And you can see that the eyes, both pupils will get constrict. And after the light is like, we shut down the light, the pupils come back to the normal mode. And here is another view of the lighting animation. So for this animation, I have to say special thanks to Kari because she showed me like how the pupils work when like get in touch with their light. And this is the opening scenes of our platform. So it is inspired by computer games because like when we enter the games, there is a menu for the user to choose. So this one we can choose like we can choose an option like male, female, or we can quit the platform. And here's the user interface. So I created a hide button for user like to hide all the controllers. So it's not like it's not annoying. Like so user can like see the atmospheres around the patient easier. And actually we can like move the camera around by using the arrow on the keyboard or the WASD. And on the top left corner ECG screen button is like when we press it, it will like show the ECG monitor, but after we press it again it will disappear. As well as the instructions button, so if we press it, it shows how the step how to use this platform. And on the eyes colors down there, it's like green, blue, and black. It is the color of the eyes. We can actually change 3 colors of the eyes. So for the future development, and adrenaline buttons must be changed because right now, as you can see, that is quite small and very hard to see it. So it will be fixed like in the future. And the heart rate of ECG monitor must be changed as well because like the sound is like not according to the ECG the heart rate. And the duration of each drug must be respected to the reality, like as I show in the philosophy in the injection. And yeah, in the future we will add more drugs and information in the ECG monitor, such as the oxygen rate. Yeah. And for the future application, the virtual scenario used as part of an array of an immersive learning experience. And secondly, the development of the other scenarios for different medications. And the final one is to create virtual patients with different disease states, because right now the patients are the patient is like has a good health. There is no disease in the patient. So acknowledgement, I have to say special thanks to Dr. Rima Kaketa, Professor Lisa P, and for supervising me, and thanks Kari Teres for helping me with the Unity, as well as James Alex. And I have to special thanks to faculty of the health science as well. Thank you.
Are there any questions for Ponpop? First, you should probably ask, is there a doctor in the house? We might need you later. There's probably actually lots of doctors, but most of you are PhDs, right? Maybe I'll ask a question to get started. Was it my imagination, but I heard a little bit of music in the background, but sort of as the pulse rate increased, it sort of seemed to me as though the music moved faster as well.
Yes, that's right.
It did?
It is, but just like the sound of the heart rate, right?
Okay.
It did, yeah, but it's like it's not according to the heart rate number that you can see on the ECG monitor.
Yeah.
Yeah, and that should be fixed in the future.
Okay.
Yeah.
Any questions from the audience over here, Michael?
What would be the main application? Is it for training purposes?
It's like for showing the students like how the drugs work, how the drugs affect on the pupils on, and like in the future we will like include more drugs, yeah, and more scenarios as well. Yeah.
So it's being, basically, would you like to add to that, Rima?
Yeah, so it's a prototype of a bigger project basically. But yes, it is to look at the drugs and their effects on the body and the trade.
There are a lot of drugs with very difficult concept. So rather as Pom Pom was saying, while we were supervising him and telling him this is what will happen, so verbally and also with diagrams, it was really hard for him to grasp because he's doing mathematics, totally
yes.
different from health science. So doing a virtual model animation, it just enhances understanding, and that's what we are hoping to achieve.
That's why he said Carly with the eye, because
yeah.
she did it on screen. She showed the eye in one eye and he immediately saw both eyes and it was very immediate. Something he'll never forget.
Yes.
And that's such a beautiful example of being able to see a reaction. We were telling him and drawing on paper, this is what happens, I was trying to put in the muscle and all that. Totally confused Pom Pom. But the minute that he saw Carly with the eyes, with the light shone onto her eye and see the constriction, he got it.
Yeah. So that's how the visualization important, right?
Yeah.
Yes. So that's a common theme across lots of different projects. You can read about it, you can hear about it, but when you see it, you start to understand more deeply than you would otherwise. Are there any other questions from the audience? I sort of saw something. I thought Tim nearly had one.
No.
Who's a doctor of something else?
Yeah, and so of course my sociological mind was going elsewhere. I was saying down the track you could actually take it out of the hospital and have like a drug education, like you can take ecstasy. But I didn't say it because then I thought, yes, kids online, they would just be having absolute fun with their avatar, making it go as crazy as possible. So probably
But that person with ecstasy will be coming to hospital. So,
yeah, exactly.
So it will be.
Yeah, but it's got wider applications, like social applications. So yeah.
Yeah, so it's a challenging world at the moment with, still in the midst of a pandemic. Hopefully we're on the back shoulder of that now, but nevertheless there's always advantages to some forms of remote education, so this will help in that regard. Any other questions before we finish off that section? No? Okay, well thank you very much, Pon Pot. Alright, so we're in the demonstration session now. Cheryl will be over here at the cylinder display. She'll also have one of the Oculus Go headsets to allow you to see one of these same experiences. Over in the back, I believe Pon Pot's project is going to be shown. All I can see is Shipwreck Amphora on that screen at the moment, but it's on the left-hand screen that you'll be seeing Pon Pot's project. And Chloe's is going to be running on the hologram table. Now we do need to lower the lights for the hologram table to operate correctly. So just be careful when you're in the room. We will sort of keep some of the lights on in the dome and wedge areas, but just be careful as you're moving around. We restart again at 11 a.m. So please rejoin us then. And the demonstrations are roughly around half an hour. All right, thank you. Are you back streaming again? Okay. We're just a couple of minutes before, but welcome everyone to the Hive Summer Internship Showcase. This is session 2. We have 3 presentations this morning in this slot with Joshua Hyde, Lee Abbott and Robert, who I'm not going to try and pronounce his last name. That's a challenge for everyone for your homework. And yeah, I might just start by saying how many people in the room haven't been to the Hive before? I think I recognise everyone's face, so that's good. But welcome to those who are attending online via our YouTube channel. That's up and running now. If you have a question, you can ask that via the comments on the stream on this side of your interface. If you're watching this in arrears, you can't ask any questions. Yeah, the summer internship scheme is a great time of year for the Hive. It's great having all of these students working on a wide range of different projects, and it's always very lively, and yeah, the results are great to see. So we will have 3 presentations, roughly 15 minutes of presentation for each speaker, with roughly 5 minutes for questions. I'll ask Daniel to keep an eye on the YouTube channel comment stream, so if there's any questions that come up during the actual question time, you can relay them. But those of you here can ask questions as well. So our first presenter is Joshua Hyde, so if you could join us, Joshua. So Joshua's doing a Bachelor of Engineering, focusing on electrical and electronic engineering, and I'll just bring up his presentation here.
And my project's not electrical engineering based?
No, that's exactly right. So the diversity of these projects is that often the student comes from an area that is totally different from the discipline that their project.
And then sort of broadening your horizon, basically.
Exactly right. So this particular project is looking at measuring and modelling the hand movement of children with cerebral palsy. So I will pass you the microphone.
And I'm presuming it's working, and hopefully a clicker works today. Yep, it's working. All right, good morning everyone, and this is my presentation. If you might know me already, which most of you do, I'm Josh. So my project is a 3D hand modelling for children with cerebral palsy and tracking hand movement. So let's get to the next slide. So just a bit of background about cerebral palsy. It's a range of conditions that affect the way the brain processes messages to the muscle movements. It's not specific. There's 4 different types of cerebral palsy and 4 different ways it presents itself. It's caused by injury or damage to the brain in pregnancy or childbirth. It's the nature of the injury that's caused is not known. Presents in many ways depending on the individual, so each individual's different. Some will gain strength in childhood with or without corrective surgery, but early intervention's really important, and this is where this project comes into play. So my project basically is to compare the accuracy and angle capture and visualisation between the IMU, which I'm using the XSense dot, and the optical sensor, which is the leap motion. An optical sensor for the leap motion is not one where you attach a suit on and have the nodes. It's actually a sensor where you can use your bare hands, so that makes life easier. And so just comparing the accuracy and the angle capture and the visualisation. Alright, my timeline. So some of these come in together basically. So literature review, so basically reading a past thesis paper of one of the students that's done this project before. Teaching myself some Unity and C#, and I can tell you C# easier than C++. And then from there, testing the capturing the angle and the formula or the mathematical script that I wrote to get the joint angle for the leap motion, and then testing the UDP streaming of the XNs dot on the computer or in Unity, which unfortunately doesn't work in here because the routers don't like it. Works at home, so I can't really demonstrate the XNs dot, but I can demonstrate the leap motion to you today. And then from there, finalise the XNs dot tracking, same with the leap motion, so finalising Unity build, making sure it looks good, validating both methods at home, so it's not a proper data validation, and we're actually going to validate it properly next week in a validation lab. Fingers crossed, hopefully no hotel quarantine leaks between now and then. And then from there, prepare the report. Alright, so the XNs dot, and I might have to come down here. So it's a self-contained IMU. So IMU stands for Inertial Measurement Unit. It also stands for many other things. It's got 9 axes of freedom. So, and the IMU, basically, it's got a gyroscope, a magnetometer, which is something I didn't need to use, and the accelerometer. So it measures those 3 things. It's got the XSense has a native app for both Android and iPhones, which you can use to get XSense data. Unfortunately, in this case, because I do need live streaming, I can't use the app. So this is where the iPad app Kind XYZ gets into play, and I'll come to that shortly. Leap motion, optical tracking device that doesn't require a suit. Has a built-in ability to track hands, and I'll show you that when we do the demo. Has a Unity software development kit, so that makes life easier, so you don't have to script the leap motion side of things. And it's got prefabs available, including your hands, so you don't need to model the hands either. Can track fingers and some gestures, but it can't track all gestures. Right, so getting the joint angle, just a bit of note, I don't completely understand Curtinian because it's complicated, and getting the rotation vector, the maths behind it's easy. Unfortunately, it's very tedious and not nice to look at, and I'll be forever here going through it if I do show you the maths. So anyway, the Curtinian, the hand and the arms are already given. So what we need to do to get the joint angle is find the common or a vector on an axis, so it can be X, Y or Z. From there, with that, and make sure the X vector is the same for both of them, then you get your rotate vector with your Curtinian and your axis you're referring to. And then from there, you get your 2 rotate vectors, you get your dot product, which is pretty simple maths, and then get your angle using arc cosine. So simple maths again. Because output in radians, you just convert it to degrees. Right, C# and Unity, I'll probably come back here. So other presentations probably don't cover Unity, but basically if you don't know what Unity is, it's a game engine. Do many things with it, but you can't do the modelling or prefab work, so you have to use something else like Blender or something like that to use it. Backscripting is written in C#, which is easier to learn than C++ because there's less syntax to worry about. Some of you are a fan of Python. Bad news is it's not Python. Me personally, I'm not a fan of Python, so I'd much rather C#. Alright, tracking with the XNs dot. So the iPad app Kind XYZ, when you first open it up, looks like this. So you have to plug the sensors in to turn them on. If you don't plug the sensors in, they won't turn on. Make sure your Bluetooth's on, and then you have your sensors will appear there, and then from there, drag the sensors across, attach them to the arm, one to the arm, one to the hand, and then you'll see, you can't see it here, but there will be a little circle there. You click on the circle and it'll give you the values. Going from there, click that arrow, you'll go to this page, and then these are the values. Attach those values, that block code there, live streams, quaternion values from this app into a UDP packet to the computer, and the UDP packet as a string, not as ones and zeros, looks like this. So basically you got your rotation of your hand and your arm, and then once that's streamed through from there into the app moves a hand, and then the back scripting that I write to get the angle basically outputs the joint angle with reference to the X. So when you have your X angle, it's basically X0 there, but because your joint angle is a difference, it doesn't really matter. And then it's got a functionality where you can record your angles and raw data into a CSV file, and that's what it produces. So you see on the left hand side, that's your timestamp, and then these are your angles with reference to the X, Y and Z axis, and then these are all your position data for your hand and also for your arm. Your position is from Unity itself, and your quaternion is from the app. Your leap motion, bit more straightforward. All you need to do is plug your leap motion in, find some blue tack, attach the blue tack to the leap motion, as long as you have somewhere to do it, and then open up the Unity build, stick your hand underneath it, and it'll show a hand. The values recorded is the same as the previous slide, and the way the angle's recorded and the CSV file's the same. The only difference is no UDP streaming, so you don't have to worry about this problem with routers or anything like that. And also, and I'll get to this later, the accuracy of hand tracking is more accurate with the leap motion. However, the accuracy in capturing your joint angle is not as good. So anyway, I'll show you, this is the first one's going to be playing. So you can see where I've put my hand underneath. The hand moves where the sensor detects the hand. You see the hand, twiggle my fingers, and it'll twiggle there. And sorry if this video is a crap quality video. It's shot on an iPhone 11 with a case on. Alright, I'll show you the next one. So that's with the XNs dot. So you rotate your hand, and what should probably part of future improvements is making sure when you tilt your arm it doesn't tilt it wrong, but basically what you can see there is it directly correlates to what's shown in the app because it's merely just streaming UDP packets. Alright, outcome with some bit of quick at-home validation. Validating the two technologies, it's a win-win situation. So your joint angle, your XNs dot, is really accurate, and it's basically very close to what the goniometer says by about 5%. If you do attach it to the hand, the accuracy will be affected because the shape of the hand and where the XNs dot is. But your visualization aspect of it, the leap motion is a lot more accurate in that sense. And if you use both of these, that's great because you'll get more benefit. So anyway, thank you Savash for helping me out with this project, and same goes to you Ian if you're watching this on YouTube. And thanks to Wesley for helping out with the Unity and the technical aspects of it. And anyone got any questions or anything like that?
please. Are there any questions from the audience? Yes, Chloe.
Obviously you're going to use the lax route towards the children. So with the sensors, how would they be involved with the children? Because obviously then they might not be happy with the stuff on them.
So for those who
How does
might,
that work?
so can you repeat the question?
Can you repeat the question?
No, can you repeat the question?
Alright.
Because you've got the microphone.
Oh, I've got the
That's for
microphone.
those people on the...
All right, okay. So Chloe was asking if this... So what were you asking again?
So obviously, like children with cerebral palsy, that might be like a discomfort to them, having the sensors on their hands, or it might be like a distraction to them. So what would be the way that you will sort of make it so they can wear those sensors, I guess, safely and sensibly?
At the moment, the sensors have been attached on with double-sided tape, but the end goal is to try and not use sensors if we can, because of course we want to try and do it with the end goal being trying to detect cerebral palsy in infants. We can't physically put sensors on infants. So that's something that might be a future improvement down the track. But that's a really good question.
If you don't mind, but what Josh did was part of my PhD research, and he didn't focus that much on the cerebral palsy aspect of things. When we put the sensors on the children, we use medical safe kits. So when we put the sensors on, we make sure that there isn't any rash or anything for the children themselves. And I think something Josh forgot to mention, this project is being done in collaboration with our health sciences department, and it's part of a bigger research that's looking at tracking angle and hand movement in children with cerebral palsy, because the current method, they use goniometers and analog methods to capture these signals. And what we wanted was, we did some digital calculations for joint angles, and Josh helped me with visualizing those calculations and visualizing this whole, project and calculation of these angles.
So Josh, have you managed to do any user testing so far? It's probably been a little bit difficult.
Haven't done any user testing yet. I think a lot of it just came down to the time, and was going to meet with the hospital people, but that didn't end up happening. Then of course had the 5-day lockdown, so
Yes.
that kind of pushed things back a bit further.
Yeah. Any other questions from the audience? Zach, over the back.
Yeah, with the limited kind of experience I have had in lead motion, I have noticed that there is occasionally times where it fails to correctly track and cause the virtual hand to jitter up and shake violently at some times. Has any thought been put into ways to potentially remove kind of problematic recordings in the hand motions?
I have sort of thought about that, but I didn't really get around to fixing up that problem, but that's a really good point. And when I do the prototype demo, if you'll find the leap motion will work about 80-90% of the time, but sometimes you'll find if you tilt your hand like this and your sensor's there, it's going to cause problems. So that's a really good question that you've asked there. Anyone else?
Are you anticipating any differences in size of hand, whether that might cause any difficulty in tracking?
I unfortunately couldn't test it on children's hands, so I can't say for the size of children's hands.
Yeah, so
I've only tested it with my hand, and it's an adult size, and I've got a pretty big hand, so.
Any other questions? If not, we might stop there, and thank you very much, Joshua. Yep, perfect. I should have asked, were there any questions on the YouTube channel? No, Dan was shaking his head. So the YouTube channel will be available after the fact, so it will remain as an option for people to view later. Now I should thank Ian Murray and Siavash Siavash is here for proposing and supervising that project. They're also involved in the next project, although they've sort of shared primary supervision of the two different projects. And our next presenter is Lee Abbott, so if you could join us, Lee. Lee is also doing a degree, an engineering degree, specialising in electrical and electronic engineering. That's actually my original undergraduate degree as well. I'll just bring up Lee's presentation on screen here. Now you might be initially thinking, how on earth do we fit a VR headset to a guide dog? That's not our problem here. That's not quite the angle of the project. And on that point, I will let Lee explain that any further. So I'll just click that into the shirt there.
Thanks.
And, there we go.
So, good morning, everyone. Today I'd like to discuss an ambitious project we've been working on, remote guide dog training utilising VR. I was supported on this project by Ian Murray, Siavash Kaksar and Wesley Lamont. This project was also made possible by Curtin HIVE and our industry partner, Guide Dogs WA. This project is aimed at enabling guide dog trainers to train guide dogs and the vision impaired from remote locations by placing a camera on a guide dog's back in location A and a headset on the trainer in location B. So why do this? Why now? Is it safe? And do we have the technology? I would give a simple yes to all these questions, but it wouldn't make sense. I think it would be better served with an understanding of the background of the project anyway. So the usual training process has two stages. In the first, guide dogs are trained and assessed in their ability to do things such as follow commands and stop at traffic lights. In this stage, vision impaired people are also assessed to see if they have the requisite skills necessary to be assisted by a guide dog. In the second stage, the guide dog and the vision impaired person are trained together, first to familiarise themselves with each other, and then eventually on a specific route to be used by the vision impaired person. During this process, they are followed by a trainer who monitors how they work together, assists the vision impaired person, and ultimately decides whether training has been sufficient. This process has been a large success, and is part of why Guide Dogs Australia has been declared the most trustworthy charity 7 times since 2013. However, when training guide dogs in remote locations, the current system is less than ideal. Sorry, I think I said 2017 for 2013. Training is heavily reliant on the skills of the trainers who must travel to remote locations for training. This causes a strain on resources available to organisations for the vision impaired, most notably human capital, with trade-offs between assisting those in regional areas and those in the city, delays in assistance, or reducing funding available for additional efforts to help the vision impaired. So this is our solution. The trainer remains in the city, the dog and the owner remain in remote and rural areas. The trainer and the trainee communicate over the phone, and video is relayed from the dog's harness to the trainer, along with information such as the dog's heart rate and the speed that they are walking, all viewed through a virtual reality headset. The system will also allow us to provide some health data for long-term use and specialised navigation and direction systems. This has all been made possible by advancements in live streaming, virtual reality, and broadband telecommunication technologies, which have made remote training opportunities viable in many fields as well. As we prepare for our first prototype, we have 10 people working on the project, with some focusing on the harness, some on capturing data, some on transmitting data, and so on. My role has been to design the user interface, which is what the trainer will see and what they'll interact with. So going into the design, there are a few principles that we wanted to stick to. We wanted to preserve screen space as much as possible, to only display what was needed when it was needed. If we did want to display information, we wanted it to be easily processed. We wanted to reduce cognitive load so the trainer could retrieve information at a glance and remain focused on the video stream, what is happening out there during the walk. We wanted all functionality to remain inside the headset. We didn't want the headset to come off. We didn't want the trainer to need to use their phone to check the weather, see where they are, to figure out which way to go. And of course, we wanted the system to be easy to use. We wanted intuitive controls, things to behave as expected, without thinking, without pause. So here's our design. In the background, we have a 360-degree live stream video. The video is stabilized at the source by the camera. If the dog leans left or right, our eyes remain level with the horizon. If we look at something and the dog turns left, the video doesn't rotate, and so our eyes remain fixed at the same spot. It's as if the camera only ever shifts position, which prevents motion sickness and allows us to use the technology much, much easier. So at the top of this, we have a summary bar, where we include information that is always important to know. Along the top, from left to right, we have a description of the dog's speed, an icon depicting health, network information, and a picture summarizing the weather. The health and network information are color-coded across a range of colors from red to green. Additional information, such as heart rate and latency, are displayed. Below this information, we have the direction system, which ties in with our map system. During the walk, the trainer can use the system to easily relay instructions to the vision impaired person. 2 lines of text are provided to the trainer as they travel from point A to point B. The top line is the instruction that gets them from where they are to the next place that they should be, and the bottom line is the instruction to be provided once they reach the next destination. The text changes size as we travel, so when we're at point A, it is about 80-20, when we're at point B, it is 20-80. This helps keep the information more easily visible while still allowing access to additional information as needed. To the right of the text, we see the distance between point A and point B, and an arrow indicating the direction relative to where the trainer is looking. In this case, the trainer might say something like, walk north for 250 meters, but that's pretty difficult to understand, so you might need to provide constant updates. And that way, as you get closer, you say, we're about 15 meters off, and then we're going to turn right. And this is actually very difficult to do with just a map or through looking through a camera to estimate this sort of stuff. Along with the direction system, the basic idea of the map system is to replace the maps application on the trainer's phone. You can zoom in or out, pan around, rotate, and includes a marker that tracks the direction of the trainer's eyes. In addition to this, the trainer can create, move, or remove waypoints to alter the journey taken with just a single button. If a marker is found within the red circle, it is removed. If there's none in the red circle, but one in the green circle, it is moved to the center of the current map view. If neither is true, a new waypoint is created, and importantly, new waypoints aren't just added at the end, they are placed in between. And this way we can edit a journey from the one that we had at the beginning, in case you need to make a detour, which is probably the most common operation that we would use, in case there's something that we didn't quite expect on our walks. When a new waypoint is created, moved, or removed, a query is sent to the map provider map box, by the way, which changes the route, which we see in blue, and it also updates the direction system, which we saw on the summary bar. And to prevent this map from obscuring our view, we have it attached to the trainer's wrist. That way we can bring it in and out of view very easily, just like using a phone. Next we have the stats window. It contains 3 categories at the moment: dog health, weather, and network. It has been designed to be modular and easily extendable though, so whenever we want to create new categories, it's very, very simple. The window can be moved around the screen, and its size can be adjusted by the trainer as well. In addition to this, any and all categories that we add can be removed with ease. This means that the trainer can move it to the position that they want and get rid of the information that they do not need. This will be very helpful for monitoring. And it also allows us to not have it in the way. We found that screen space was the most important thing for us. We don't want to have this obscuring anything and have it stay in one spot. So putting all these pieces together, we see that the design allows itself to be used how the trainer prefers. When the trainer wants to see the map, they simply raise their hand. They want to monitor information, they select on the stats window, place this window wherever they please. To be notified of any issues, the stats window does not need to be open. We have the most important information in the summary bar, and it can be viewed at a glance. This allows the display to be pretty much free from any information except that which we have decided must always be seen in case of emergency or so on. And that's the project so far. It's still in development. There's a few changes we'd like to make. We want to make the UI more accessible. For example, make sure that trainers with colour blindness can use it. We think that the direction system may be simplified and refined further. We hope to include functionality for public transport as well. There are many small yet important features like checking the time, being able to see which way the dog is facing on the map. But most large decisions, such as control schemes and UI composition, are likely to be driven by testing. At this point, the design exists as a prototype to facilitate discussion and garner feedback. We are expecting the design to potentially change a lot as we add and remove features or change how they're implemented. That was it. Thank you.
Are there any questions?
Sivash?
I think it would be more if you mentioned the current process, if someone wants to go to a new pathway, how people are doing it now, and why there is a need to do this process.
Right. So at the moment, if there's a new pathway, essentially, like if someone who knows how to use a guide dog moves to a new place and we need to figure out how they go about, their daily life, we have to send someone out there to train the dog. And in the city, this is relatively easy, just drive out there, train them and so on. But if it's in a remote or rural location, we have to book hotels, catch planes, the person has to spend, up to weeks there with the person. And this is okay, except it means that the trainer has to work only with one person. And so that's where the strain on money and human capital comes in. And yeah, it's very difficult and it's a problem that we'd like to solve.
So, follow-up question. So, initially you're looking at people who are trained and like they've already got a relationship with the dog, they're going to handle the dog potentially. So I'm thinking about your initial safety concern, the person who's you're simultaneously teaching them how to train the dog for the first time, and the person's not physically trained, it's not physically there. You're saying it might need more use of people that already are trained in the dog that move to a new situation.
So no matter what, they do receive training with the dog, but they receive it first not on the road. They go out and they learn how to use the dog, but they will still need to be monitored when they eventually do go out and use it. I don't think we've decided whether it's going to be used for people that have lots of experience yet or people that have had no experience on the road, but I think that at the very least it will be useful for people that have had lots of experience. It's the sort of thing that we're going to have to find out, just from using it. Yeah.
I'll just add something to that. And the idea is, it's not to train people how to use the guide dog. They already know how to use it. It's just train them to go to a new path. Because regardless of whether they know how to use the guide dog or not, as soon as their path changes, they want to go to a new shopping center, a new doctor appointment, the trainer has to go with them to the new path, go there a couple of times, make sure they're handling the dog correctly. And the health information comes in when the trainer goes there to visit the guide dog and train the person. They will be monitoring the dog as well. So the idea is we'll have that. And some of these will also be applicable for stage before the dog become guide dogs when we're raising them as puppies. So tracking their movement and potentially looking at if they're developing any signs of limping and lameness in the future. So we can track that while we're monitoring their behavior throughout these exercises.
So are there any more questions? Thanks, Sivash. Zach?
I know that you've been mostly responsible for doing the UI, but has there been any actual practical tests using live stream footage with the current setup that you've created?
We have set it up with live streaming from a camera. We don't have it doing that today just because we thought there might be something that goes a little wrong with it. But we have been able to do that. One of the main things that we're looking at is figuring out the quality, so balancing the resolution and the latency and stuff like that. But that's being worked on separately as part of a different project. Yeah.
Great. So how do you envisage user testing of your component?
I think that's the sort of thing that we're going to have to discuss with the people from Guide Dogs WA and figure out what they think is best, because it is a bit of a safety concern. But for sure, like, until we get a bit more involved with that, we can take out dogs and, you know, put the camera on the back and just start to see like what we think doesn't work for us already, narrow things down, and then we can present a more full product, that sort of thing.
Yep. What was the question, Tim?
Sorry, just very hard. You mentioned right at the start there's a lot of kind of like minor head movements were cut out, so you don't get sick, so to speak, kind of remains focused on the front.
Yes.
You don't have much detail, but was that a relatively simple problem to solve? Or
Oh, that's a problem that was already solved by the camera that we're using, yeah, the Insta360 1X, yeah. Yeah.
Yeah, because that's a problem of the world moving around you. One of the advantages of these headsets is as you look around, you know, that the world stays stationary. You don't normally have this problem with just a normal video camera because it's not fully immersive. But once you're fully immersed, and it becomes your brain uses visual information to get your own position in the world. So if it's moving around, it makes it feel as though you're moving, and that can induce motion sickness. So it does need to be stabilised. So actually it's good that it's already implemented within the camera.
Yeah.
So can you imagine a day when it might be that someone might just have this strapped to their dog all the time, and if they have a problem out on the road, say for example there's some roadworks or something and their normal path is blocked, they might be able to call someone up saying, I've got a problem here, I don't know where I am, or do you think your system could be used in that scenario?
I definitely wouldn't rule it out. If it's a very successful system, then maybe it gets implemented on a wider scale, gets a bit cheaper to make and stuff like that. And yeah, it definitely seems like a good idea. I don't think that's one we'd actually properly considered yet. But yeah, it definitely seems like something that could happen in the future.
Because these cameras aren't super expensive, but of course...
they're relatively new as well, and so they could become a lot cheaper very quickly.
Yep. Any other questions? Lisa?
I just want to add that, and thank you for sharing this. It's really, I think it's going to be very beneficial. I'm just looking forward to see it in action, because at the moment I just can't visualize how the whole thing works. As you were presenting, I was trying to sort of visualize.
And
it is very difficult,
yes. Where those headsets are, right?
Just trying to visualize the whole thing.
Yeah, I definitely look forward to showing you with the demonstrations that we have after. Yeah. Yeah.
So we will be having demonstrations afterwards for all the three presenters in this particular session. So I encourage you to stick around and look at those different projects. But at this point, I think we'll thank Lee for his presentation.
Thank you.
That's you. I'll let you walk away with that. Thank you. So at 12 o'clock we will break for demonstrations. Over in the dome area we'll have the Joshua's project on the cerebral palsy. In the wedge area we'll have Lee's project. I don't think we've got the guide dog today. That's a joke, by the way. And in the cylinder we'll have Robert's project. So let's just tap across now back to the program, and at this point I think I should introduce Robert. I'm not going to attempt to pronounce his last name because I know that I will get it wrong, but Robert, now let me remember, is doing a Master of Science with a major in geospatial science. So it's great that we had a project that is geospatial in nature, but obviously interplanetary rather than Earth-based. And so he's been working on a project that's supervised by Anthony Legain and Gretchen Benedicts. titled A Tool for Visualising Planetary and All-Sky Astronomical Data. And this project has been supported by the Curtin Institute for Computation, so we thank them for their support of this project as well. So, I'll give you the microphone.
Thank you.
And over to you, Robert.
Okay. Hi again, everyone. As you know, my name is Robert, and it's a great pleasure for me today to present to you my project, which is about the development of tool for visualizing planetary data. So let's get started. As you know, imagery is one of the most important data sources, as it can provide the most current and the most important detailed information about an area of interest without actually going there. And currently, due to the advances in remote sensing, the image resolution has dramatically increased from kilometers to centimeters per pixel. So there are challenges in managing those data sets because they come from multiple sensors, they are high resolution, and they are large in volume too. And also, they require a long processing time. As such, traditional image processing becomes very inefficient, and a new tool is required to process fastly those images and then to visualize them smoothly to facilitate the analysis and interpretation in order to extract useful information. So now, let's move on to the aims and objectives of this project. So, the primary aim of this project is to develop a tool that can display high-resolution images efficiently and in a timely fashion. So the objectives are first to automate the physical mosaic of those tiles, then use display software such as Pano Tool and Kair Pano to visualize those images in a flat view display on the web browser. And also one of the objectives is to virtually mosaic some tiles of images and then visualize them smoothly with a spherical display cesium. Now let's move on to the study area and data. So for this project, the study area is Mars, because Mars is the most similar and the closest to the Earth, and it is also the most studied planet after the Earth. In terms of data, we have used the context camera, or CTX, which is the best global imagery available for Mars until now. Last year, a machine learning algorithm have been applied to the whole CTX data to detect automatically the craters. That algorithm could detect the craters down to 50 meters in size. Why? Because craters are really important to determine the age of the surface of a planet. So this project is very important to examine the efficiency of that algorithm called CDA for subsequent analysis, which the team are going to use to visualize the detected craters with the imagery. Now, let's talk a bit about the CTX imagery. The CTX dataset covers almost 97% of the planet Mars. It is an 8-bit grayscale imagery with 5 meters resolution, and the imagery are available in 2 degree by 2 degree tiles from the global coverage of CTX mosaic. And for the entire planet Mars, there is almost 15,000 tiles, which is equivalent to 5 terabytes of data. For this project, there are two tiles available. The first one is in format UATIF, which is directly downloadable from the NASA website. And the second one is the tiles already processed, and they are available in PNG format. So let's talk now about the methodology. We have used 2 methods to visualize the CTX data. The first one is to physically mosaic the PNG tiles, that is, they are already processed by the CDI or crater detection algorithm. And we have used Python scripts to automatically stitch together some tiles. And then after that, we have used the display software, Pano2 and Pano, to tile the physical mosaic into small tile of 512 by 512 pixels, and then display in a flat view browser like this. And the second method concerns a virtual mosaicing. The virtual mosaicing is based on the use of the geospatial data abstraction library, which creates a virtual file in a XML data like this. It is an XML data that points to every raster, and then GDAL is used again to reproject and tile the virtual mosaic, and after that the tiles have been ingested in a spherical view display like this. It is called cesium. So in terms of data processing, all the data has been processed with a desktop computer at the Space Science and Technology Center, which have 8 cores and 12 thread CPU, and the computer has 128 gigabytes of memory. And for the scripting, we have used Python 3.8 version with the Conda environment, with other libraries such as NumPy, OpenCV, and Pillow Image, apart from GDAL. Now, let's move on to the result. As you see in the table, this concerns a 6 by 6 tiles of image, and the first line concerns the mosaicing time with GDAL, not with GDAL, but with Python. And as you see here, the total time to prepare all the data before viewing is roughly 3 hours and 35 minutes for Pano2, and for Pano, it is 3 hours and 45 minutes. And in the first figure, it is a sample of display with Pano2 Pro, and this one is with Pano. As you see in the picture, Pano is a little bit better in terms of zoom in compared to Pano2. Now, this is the result of virtual mosaic. As you can see in the table, the virtual mosaicing is very, very quick, as it takes only 10 seconds for the same size of image. But for this one, the problem is the reprojection and the tiling, which takes almost 3 hours. So let's move on to the discussion. So for the tiles already processed, which are in PNG format, only the physical mosaicing is possible, because those tiles that don't have any spatial references. And the visualization with Pano2 and Pano is limited by the long processing time and the zooming. And also, the pre-processing time increases exponentially with the size of the mosaic, and it is also largely dependent on the performance of the machine used and the memory. But on the other hand, virtual mosaicing is very efficient, and it is much faster compared to the physical mosaicing. And also, we use in this virtual mosaicing the parallel processing approach, which makes the data processing much faster. And finally, with cesium, unlimited tiles can be ingested. So let's move on to the conclusion. So we have started to investigate the the visualization of physical mosaic tiles. They have already the craters on them, and then we visualize them with display software Pano 2 and Kayo Pano. We have seen high quality display despite some limitations such as the zoom in and the long time processing. And we can conclude that the virtual mosaicing is the best solution to visualize high resolution imagery because it is fast and it is also easy to update. And we have concluded also that cesium is the best display for high resolution imagery because it emulates better a planetary body. So for future work, a tool that can process automatically all the tiles of the planet Mars can be a great idea to visualize all the entire data set. So before finishing, I'd like to thank the Curtin HIVE for funding this project, Anthony and Gretchen for my academic supervisor for their precious guidance throughout my internship. I'd like also to thank Wesley, my HIVE supervisor, for his technical support. And lastly, I'd like to thank Rakib, a HPC specialist at Curtin, for his assistance on data processing. So thank you so much for your attention, and feel free to ask if you have any questions.
Are there any questions? I'll start out with one question then. You quoted some processing times there. What sort of computer were you using for that processing? Was it just a laptop or a desktop?
It was a desktop.
Or the Pawsey supercomputer?
No, it was a desktop computer at the Space Science and Technology Center. Mm-hmm. Yeah. But it is a bit strong computer compared to a normal computer.
And that processing was, for one, was it in Python, or is it, what were they? I think one was Pano 2 Pro you listed.
Yes, and one is with Kayo Pano, but most of them is in Python script.
Yeah.
Yeah. Especially for tiling. Yeah.
Mm-hmm. Okay. Any other questions from the audience? Zach?
Yes. I believe that you went through and explained that you use the kind of algorithm to document and locate all the dents and craters along the surface of Mars. Were there any kind of errors or miscalculations by the computer recognizing certain areas as craters that weren't actually craters?
Yes, as I said earlier, they have used a machine learning technique to detect those craters. Yes, I believe there are some errors, but before that automatic detection, the craters was counted manually by scientists, and one of a point of comparison is the comparison of those manually counted craters to that automatic detection, but they found a high correlation between those two methods. I think that the correlation is more than 90%. So there is still some errors, but not very significant.
Any other questions from the audience? So you have implemented visualization both using Kayo Pano and also cesium.
Yes.
So we'll be able to see those on the demonstrations.
Yes. Yeah, I started from simple because with panel 2 and carbonate simple, and then improve to the best quality, which is cesium.
Yep.
Yeah.
Yeah. And so the main problem with KO Pano is the massive size of these the total resolution that the
Yes,
planet has been mapped.
and also the problem is with panel 2 and KO Pano, they tell the big image to a 512 pixel by pixel, but for GDAL it is 256, which is smaller, so the display is much faster with cesium, but compared to KO Pano and Pano 2. So it is smaller, but the problem is it's going to be a big file after the tiling because there are lots of small files.
Question from the back. Oh, there's a question from YouTube.
Yes, Gretchen Benedict is asking, could processing be parallelized from Corsi?
So is this, I guess it would be, since it's Robert's project, the parallelizing of the ingestion or the conversion of the original content to either the KR Pano or cesium platforms.
Yes, we thought of running with a POSI, but we didn't really do it.
Yeah.
Maybe for the future work.
Well, it's not such a huge load for processing to convert the files to run on either cesium or KR Pano, is it? As you know, if it is 3 hours, then that's not a huge deal. It's probably take more than that to get it running on Corsi, right?
Yeah, because we just take some samples of imagery, but as I said, for the future work, when they process all the data for the entire Mars, I think the POSI is a good solution.
Yep.
To process all the data fastly. Yeah.
So POSI is currently being used to detect all of the craters. That's what the CDA stands for, the crater detection algorithm. And then it's outputting the PNGs. And so perhaps just a little bit of extra code on the back end of that program could then generate the output that's immediately able to be uploaded to cesium or KO Pano for that matter.
Okay.
Yeah. Any other questions from the audience? This is a little bit otherworldly for everyone, I suspect. But thank you for your presentation, Robert. And please join me. Thank you. We'll now switch over into our demonstration session, which is going to be showing the work of Joshua, Lee and Robert. So I believe Robert's work will be shown both on the tile display and the cylinder. Let me just go back to our program so we can see where our timing is. Lee will be over here in the wedge display, and you can see it showing on one of the panels just there. And Joshua's over here in the dome area. So please go and have a chat, have a try out with their different visualizations, and we will be closing the room at 12 to make sure everyone goes and gets lunch, especially Daniel, Wesley and Carly, and then we will be restarting at 1 o'clock, and sorry, I mean, because it's 12 o'clock now, isn't it, practically? No, I'm reading the wrong line. Demonstrations are for roughly half an hour. We'll be breaking for lunch at 12:30, and we've got half an hour to grab something to eat and then come back for our next batch of presentations, session 3, starting at 1 o'clock. So look forward to seeing you here at 1 p.m. for session 3 with Shuchi, Hassan, Zach and Ayush. See you then. Alright, so we're going to make a start. My name's Andrew Woods, I manage the Hive, and see two new faces, so welcome. In this session, the third session of the Hive, Curtin HIVE Summer Internship Showcase, we have 4 presentations. 3 of these are in collaboration with the West Australian Museum, so that's a great link that we've had with the museum over many, many years. And in fact, the Curtin's links to the museum date back as far as the 1970s, when the Batavia shipwreck was originally excavated. So my former boss, John Penrose, took part in some of the dives on the Batavia site. And yeah, so it's good to continue our links with the museum over that long period of time. Just a little bit of housekeeping. We will have 4 presenters in this block. Each presenter gets roughly 15 minutes for presentation, leaving roughly 5 minutes for questions. If you're watching this on the live YouTube stream, then just enter any questions you have into the chat, which is on this part of the window. If you're not watching it live, sorry, there's no questions for you. And after those 4 presentations, we'll have demonstrations around the room. Now let me just remember here, actually it's on our screen here, we've got Shuchi will be on the cylinder, Hassan will be on the wedge in the back of the room, and his visualisation's already on screen. Zach will be in the dome area on the big screen in there, and also using the looking glass 3D display. And Ayush will be using the tile display, which is the one we can see here. Alright, so our first presenter is Shuchi Ganesh. So Shuchi, if you can join us up here. And I'm just going to click on your monitor here. Welcome, you're being applauded already. Shuchi's presentation is titled Fremantle Panoramas Exhibition, and Shuchi is currently studying towards a Bachelor of Arts with a major in History, which is a good alignment with this particular project. This particular project is sort of a launching point from the Historical Panoramas project, which started out as a Hive summer internship 5 years ago. So the original student who worked on that project did such a great job that we did the further work to launch it as a public website, historicalpanoramas.com.au, and it's now great to see the project evolve even further. The State Library has been a great collaborator on the Historical Panoramas project the previous stages, and it's great to see the WA Museum taking on taking up this project even further. So I will pass on to you. I'll just clip it onto your shirt here. There you go. Over to you.
Hi everyone, my name is Shuchi, and as Andrew just mentioned, I'm an undergrad history student. And over the course of this 10 weeks of internship, I was working on a project titled Fremantle Panoramas Exhibition. Before I start discussing the project, I would like to first acknowledge the traditional custodians of the land, the Whadjuk Noongar people, on whose land Curtin University is located, and I also pay my respect to Whadjuk Noongar elders past, present, and future. Aboriginal and Torres Strait Islanders are also warned that the following presentation contains images and stories of people who have died. So I would like to first begin by introducing my project. So the Western Australian Museum is intending to display the Fremantle focus parts of the Historical Panoramas project, along with various other images and collections related to historical events of Fremantle at the temporary exhibition gallery in WA Maritime Museum. So the Historical Panoramas is basically a public website which was created in collaboration between Curtin HIVE and State Library of Western Australia. So it provides a virtual tour to visitors to explore how the city of Perth and Fremantle has changed over time through these panoramas. However, the WA Museum is intending to propose only the Fremantle focused parts of the historical panoramas alongside various other stories. So following the intentions of the WA Museum, here are the aims of my project. So the first aim of my project was to create an exhibition brief. So this exhibition brief will be used by the WA Museum for future exhibit planning. The second aim was to identify some of the significant stories that could be potentially displayed in the exhibition. Third, to analyze the historical panoramas. So as I said, the historical panoramas contains many panoramas of Fremantle. So my main job over here was to analyze and interpret how the city of Fremantle has changed over time through these panoramas. Fourth, to search for archival materials, images, and collections related to Fremantle. And finally, I also had to investigate some of the ways in which the stories and the panoramas could be exhibited in the exhibition. So what are the outcomes of my project? I created an exhibition brief which outlines in detail the key message, themes, exhibit list, and the visitor outcomes expected from the exhibition. To be precise, the exhibition brief is 50 pages long and it details all information which is required for exhibition planning. And over the course of this internship, I also did an extensive research on what kind of stories could be displayed in the exhibition. And these stories have been divided into 5 themes, and these themes have various sub-themes in them as well. So these 5 themes are, the first one is called Aboriginal or Walulup history, and the second one is the history of Fremantle Port. Third, the panoramas. Fourth, Gold Rush history, and lastly, the celebrations. And as I said, I also investigated ways in which these stories will be exhibited in the exhibition, and overall the project came up with 26 exhibit lists. Now I would like to take some time in briefly describing what these 5 themes are and the exhibit examples. However, I won't be able to go in detail and showcase all the 26 exhibit lists because of time constraint, but I'll be showing some of the exhibit examples which seem to be really interesting to me. So the first theme is called Walulup history. So Walulup is a Noongar name for Fremantle, and it actually means the crying place. It is called so because it is believed by the Noongar people to be the place where a person's spirit lives when they die. It's a very interesting story. And this theme covers something known as knitting. So knitting means creation stories. So it gives a Noongar perspective on how Walulup was created and the various ancestral beings that were involved in the creation of Walulup. It also covers some of the traditional sites in Walulup. So Walulup itself is a very spiritual place for Noongar people, but to be specific, in Walulup, the Cantonment Hill, Swan River, and Rocky Bay are really high cultural and spiritual significance to Noongar people. The theme also covers the story of Yagan. So Yagan was a very popular Noongar figure who bravely fought the colonizers. So here's an exhibit example. So to display the story of Yagan, it is being proposed to create a bust of Yagan. I feel it's really important for visitors to understand and hear to our local Noongar voices in their stories, because it really creates awareness among the visitors to maintain these stories for the future. Moving on to theme 2, that is the history of Fremantle Port. So this theme pretty much covers the entire history of Fremantle Port, from its early days of colonization to its most contemporary usage. So it starts with the early migrants and their contributions. So when the Swan River colony was established in 1830, many people migrated to Fremantle. So it includes the stories of these early migrants and the various buildings that were constructed during this period. For instance, the Roundhouse, the story of the convicts, and the various buildings that they constructed. And then we move to the construction of the port. So how was the port constructed and why was it constructed? And then the port usage during wars. Fremantle was a very significant port during both World War I and World War II. And then we move to the post-war migration and the changing nature of the port. So here are a couple of examples on how some of the stories belonging to these Team 2 could be exhibited. So to display the story of Roundhouse, it is being proposed to create a 12-sided polygon using false walls. So as the Roundhouse is a 12-sided building, we are proposing to create a 12-sided polygon using false walls, and the stories and images of Roundhouse will be displayed in the inside walls. So the inside 11 walls will be used to display the stories and images of Roundhouse, and the 12th side will be left for entry and exit. So basically we're creating a model of Roundhouse in the exhibition. Another example, so this is to display the story of the changing nature of the port. So it is being proposed to stack all photographs of Fremantle Port in a timeline. So for instance, so when we begin with this, I don't think this, yeah. So this image over here, this is an image of Fremantle Port which was taken in 1899. So this contains some warships. And as we move to 1913, so warships can no longer be seen, and so you can see steamships. And as we move a long jump to 1970, no steamships, no warships, and so you can see some container cargoes and cranes being used to unload the goods. And moving to 2019, container cargoes are still seen, plus a cruise ship. So this is the beauty of photography. So just through photos, you can understand how Fremantle Port has changed, how it has transformed, and the different role the Fremantle Port has taken up in different periods of time. Moving on to theme 3, that is the historical panoramas. So Fremantle and its surroundings have been beautifully captured by photographers from the late 1800s to contemporary times. So the panoramas provide a visual evidence and also engages the visitors to understand how Fremantle has changed since colonization. And not just that, it also helps in understanding how technology has improved over time and subsequent improvements in photography. So to display the historical panoramas, it is being proposed to display the historical panoramas on a large screen, preferably curved, similar to the cylinder screen over here. And there'll be touchscreen plinths in front of them for interaction. So visitors can actually zoom in and zoom out and see how Fremantle has changed over time. So this is a very interactive exhibit, and visitors can actually really feel the vibe of walking through a historical Fremantle and see how it has transformed over time. Moving on to theme 4, that is the gold rush history. So when gold was discovered in different parts of Western Australia, migration to Fremantle increased by great heights, and many buildings had to be constructed to support this outgrowth in population. So some of the buildings that this theme is going to cover are the National Hotel, Literary Institute, Federal Hotel, Orient Hotel, Esplanade Hotel, and Manning buildings. So this theme will actually cover some of the strange or unique stories that happen inside the buildings, and also at the same time look at the architectural wonders of these buildings. So here's an exhibit example. So it is being proposed to display these buildings through projection mapping. So here's an example of projection mapping of Orient Hotel, Esplanade, Federal Hotel, and Esplanade Hotel. So false walls will be used to cut it in. False walls will be used and cut into shallow triangles, and they'll be cut further into the shape of the buildings to reflect those intricate details of the architecture. So during the period of gold rush, Federation Free style of architecture became really popular. So this Federation Free style of architecture is a blending of classical and also modern style of architecture. So when these buildings are projected, so you can actually see those intricate and very delicate details of the buildings. Moving on to the last theme, that is celebrations. So this theme revisits some of the celebrations or festivals that have happened in Fremantle. Fremantle is often known as a city of entertainment. It's a very vibrant and energetic place. So some of the events that this theme is going to cover is the America's Cup. So the 1987 America's Cup was held in Fremantle. So it's basically a sailing event. ISAF, that is the International Sailing Federation, that was proudly hosted by Fremantle in 2011. Rally Australia is an automobile event which ran for the very first time in Fremantle in 1988. Fremantle markets and Fremantle Festival, they're really vibrant always. And you have the one-day event. So one-day event is actually a very recent event which started in 2017. So it kind of brings people together and discusses what's really great about being Australian. So this year's theme, that is 2021's theme, was to celebrate and appreciate the traditions of Noongar people. And then who can forget the 2013 AFL Grand Finale? So although Fremantle lost the match, the entire streets of Fremantle were jam-packed and overcrowded. So, and the Blessing the Board. So Blessing the Board is a very ancient festival which was started by Italian migrants when they first migrated to Fremantle in 1948, and it continues to be celebrated even today. So here are a few images. So this is a picture of Blessing the Board being celebrated in Fremantle in 1961. So this is a picture of America's Cup of 1987. You can see how overcrowded Fremantle is during the celebration. And this is a picture of the Fremantle festivals in 1990. So a street parade is going on. And this is a picture of AFL 2013 when Fremantle was really jam-packed, and they're kind of cheerfully looking at the match on LED screens. So it has been proposed to display these images on walls so that visitors can actually really feel a sense of how Fremantle was looking during these celebrations. So these are the 5 themes and some of the exhibit examples. I would also like to show you all a floor plan. So this floor plan will give a general sense of how the exhibition will look like. So here is the entrance to the gallery space. So as soon as a visitor enters, the first thing they should be able to see is a Welcome to Country video by a Nunai elder. So as they move through that, so both on the right and left hand side will be exhibits related to theme 1, that is Walulip history. Moving from that, so they should be able to come across exhibits related to theme 2, that is the history of Fremantle Port. So starting with the early migrants and the contribution, the stories of the convicts and the various buildings constructed by them, and then moving to the original photographs belonging to construction of the port sub-theme, and opposite to that will be this changing nature of the port. So this entire wall will be taken up by this changing nature of the port. And as we move through that, there'll be a few other original photographs of how Fremantle looked during the war period. And then next to that will be the centerpiece of this exhibition, which is the panoramas, which will be displayed in a huge curved screen. And opposite to that is the model of the roundhouse, which I just discussed earlier. And this entire wall over here will be taken up by the projection mapping. So the various buildings that were constructed during the period of gold rush will be displayed through projection mapping. And almost at the end, so this entire falls wall will be taken up by the celebration. So that will be filled with images and videos of Fremantle celebrating itself. So as you can see, so the general flow of this floor plan is in a timeline. So you start with the most ancient, that is the Walulip history, and end with the celebrations. So visitors should be able to really learn and also enjoy at the same time the history of Fremantle. And last but not the least, I would really like to acknowledge and thank my supervisors, Dr. Bree from the School of Media, Creative Arts and Social Inquiry, Carly and Andrew from Curtin HIVE. I would also like to thank Donna and Tanya from the WM Museum, and thank you all for being such a wonderful audience.
Are there any questions for Shuchi? The bucket just from the chair. Must be a question. I know this project too well, so I haven't got any questions. Do you have a favourite panorama from the, or perhaps a favourite part of the panoramas?
I think like the view from the South Mall is really beautiful. Mm-hmm. So it gives the entire view of the layout of Fremantle. So that's one of my favourite. Mm-hmm. Yeah.
And where's that from?
South Mall.
Oh, from the South Mall. Oh, yeah, that's true. Yeah. So that's.
Yeah, I can show that during the.
Yeah, you can't even see it here because it's in the middle of. So this is even before the South Mall was constructed.
Yeah.
Yes. Question from the back, Chloe.
When is it going to be sort of proposed to go?
So next year from March to July. Yeah.
Just
it cannot be guaranteed.
So
it cannot be guaranteed.
Not confirmed.
Yeah. That's it.
Question? Like I said, I know this project too well, so question over here from Jill.
Do you think the wall that will have the celebration photos could become digital as well, or would that interrupt the rest of the space, do you think? Because I think it would be great to actually get video of the celebration?
Yeah, it is being proposed in the brief that the celebrations will have videos and images as well. Yeah, but I think for the presentation I just show the images. Yeah. Yeah.
Yeah, I guess it all depends upon how many projectors are available.
Yes.
So, if you want to include video, you need projectors to do that. Whereas if it's sort of static, then you just be able to print vinyls. Although a vinyl of that large size might, itself have a fairly high cost. But yeah, there's sort of all of these ideas need to be balanced against a final budget. So it's Shuchi has come up with lots of ideas in collaboration with the supervisory team, and these can all be weighed against all sorts of different options. Any other questions from the audience? So we're actually right on time. So at that point, we'll thank you very much for your presentation. Next one, there we go. So our next presentation is from Hassan Al-Sayed. So please join us, Hassan. Hassan is a PhD student in the Faculty of Science and Engineering, and he's been working on a project that we've had a few nibbles at before in a different way. So this is working on a shipwreck that was dating back from about 300 BC, was discovered off the coast of Cyprus, I think, in the late 1960s. I'm probably stealing half of Hassan's presentation here, aren't I? In fact, we had a project last year that looked at one aspect of this, and now this project is looking at a different aspect. So it's good to see some continuity between projects, and it allows sort of a deeper analysis and a further study. So at this point, I think I'll pass to Hassan, who can tell you more about the project.
Okay, hello everybody. I welcome you here, and it's a pleasure to be here today.
Oh, sorry.
No worries. I got it.
It's going to do what it's going to.
So it's a pleasure to be here presenting at HIVE. Today I'm going to talk about my project here is creating a 3D model of the Kyrena shipwreck cargo. First of all, let me introduce our shipwreck. This ship, Kyrena, was one of the most interesting ships at the 3rd century BC. It was discovered at the north coast of Cyprus at 1967. Then they started to extract and excavate the whole location for 2 years, between 1967 till 1969. During this excavation, they used around 300 films, and of course they were just black and white films at this time, 50 years ago, and about more than 10,000 pictures were taken. About the cargo itself, mainly it consists of two things. The first is the amphoras, which is the most interesting item. Mainly it was one sample of amphora, but this was the dominant one, but there was also other kinds or shapes of amphoras. Also we got the millstones at the bed of the ship. The objective of this project simply is transforming the 2D images, okay, into a 3D model here, as you can see. So the 3D model can be used for further steps. Then repeating this step for the following levels and build the temporal 3D models for the whole cargo. So simply when they discovered the ship, divers started to remove and extract all the amphoras at the surface. Then they got another surface underneath and they started to extract it, and so on until they reached to the bed of the sea, the bed of the ship. So building all the 3D models for the whole cargo, was the second step. And the third one was building a 3D CAD model for the cargo, for each level, and consequently for the whole cargo. So the purpose of the whole thing is studying how all of these amphoras were stacked together under the sea before extraction. And this will give us, or give archaeologists particularly, more obvious and more clear side view for the whole cargo, so that they can know or get more evidence how this ship was sunk at this time, and consequently they can conclude some historical events or rectify some historical information. So how is this done? How this was done? First, I used a bunch of software packages, mainly Metashape, then Rhino, oh, not this one, not this one either. I need help. Yes, this Rhino. Also, we got this normal stuff like Word, Excel, PowerPoint, Microsoft Teams for communication. So mainly, Metashape, do you remember this slide, was used to transform the 2D images into the 3D models. After that, used Metashape again to build the temporal levels of the cargo, but this time we needed to link these levels together, so I had to use the professional version of Metashape this time. This professional version offered us like what's called a feature called reference points. These reference points could be just defined on the same features, which is located at different levels. So these reference points can be used to link the different levels together. And the third step, to transform the 3D model into the 3D CAD model, I used the Rhino for this job. Okay, so the obstacles during this project, mainly discovering the whole thing, because too much data, as I mentioned, too much images, too much software to be used, and so on. So discovering the whole thing was a little bit hard, but with intensive meetings with the supervision team, it was super fast. Then when I started to build the 3D models from the images, I started to get very distorted models. And by investigating this data, I got two main reasons for this distortion. The first one is having a repeated images, not identical ones, but just the same perspective, the same images with maybe like a light zoom in or zoom out, like the two images above at the center, or have an unclear image, like the bottom one at the center. So these two reasons caused a lot of distortion for the model. So removing all of them was a good idea. And as you can see at the third image here, a lot of obstructions, okay, tubes, pipes, suction tube, ropes, and so on. All of these features caused a lot of confusion for the software during the 3D model building. So what happened to remove these obstacles? First thing was filtering the whole data, so investigating all the pictures and the images, remove the repeated images and remove the unclear images. Second, make what's called masking. This masking is just removing the unwanted features, because these features not only causing like or working as an abstraction in the image, but they were also movable between image to another, one for the same view. So it caused a lot of confusion for the software to build the 3D model. And also by thoroughly investigating this data, I started to repeat the classification and the gatherings of the images and make many chunks. Like, so we got level 0, level 1, and level 2, but after investigating these images again, I found that we have to separate level 2 into level 2 and 3 level 1, it also got many sub-levels like 1A, B, and C and D, but eventually I had to combine them into only 1A and 1C. So these chunks really helped. And the final step was what's called histogram equalization. This was like a Python code. This code, as you can see here, this is the original image, and by using this Python code, the quality and the contrast of this image improved a lot, and the same for the lower one. So this histogram equalization was done for the whole package, for all images, and it improves the quality of the 3D model much more. The results, simply, we got our 3D model for the whole cargo. This is for level 0, and this is the 3D model for level 1A, and this is the CAD model for it. This is 1C, and this is the CAD model for it. This is level 2, and this is the CAD model for it. And the final one is level 3, and this is the CAD model for it. So eventually I got the 3D CAD model for the whole cargo, as you can see right now. So the job has been done. Okay. A few things that I have to consider, or especially for the future work. First of all, the resizing the amphora when matching the 3D CAD model for the amphora to the amphora in the 3D model, which is done by Metashape. I had to resize manually this amphora, so there is an expected error during this process. Also, matching this amphora to its location in the 3D model, I got 6 degrees of freedom. So rotation, moving back and forth. So all of this, there is an expected error in this process also. And the final thing is an expected error during the linking between different levels and different layers. So yes, it's practical and it's workable to build 3D models for some data which is collected 50 years ago, black and white, very rough. Okay. The precision of the output is need to be discussed and need to be considered for the future work, so that the following interesting people can just know how much precision you can get from such a method. And this could be done through measuring the differences between the same features or the same amphoras which is located in different levels in the 3D CAD model. So by measuring this difference or this error, we can get some insights into how much precision we can receive. I really need to give big thanks for everyone here at Hive, the supervision staff, David, which is I hope to be here. Jeremy, of course, from WA Shipwreck Museum, of course, Andrew, also Daniel, give a lot of help, Carly and Wilsey. They were really supportive and they just transformed a big problem like to this small. That's it, and any questions?
Questions from the audience? Just time for me to ask one. How many amphora did you place?
Too many.
Too many?
Over 100, yeah. But there is a lot of repeated amphoras, as I mentioned, yeah. Because many amphoras were just settled or matched in a certain level, and some of them were in the following levels or at the previous level. So yes, but at least 100.
And do you think that's all of them? Do you think that there have been any that have been missed?
Yes, of course, because as I mentioned, the 3D model, during the building of the 3D model using Metashape, many of images were very rough, not too much details were available, so a lot of parts or areas in the 3D model were just very rough and they didn't show too much details or enough details to be to give the opportunity to match more amphras. Also, there was a lot of broken amphras, and these broken amphras, it is not a good idea to match or consider them in the 3D model because they are moving with water waves and so on. So they could just give some false information. So it was like an advice from Jeremy not to consider the broken amphras. Yes.
Yep. It was a shipwreck after all. So
yes.
Not surprising that some broke, but it's actually probably surprising there are so many that didn't break.
Yes. Yes. Of course. Yes.
Any questions from the audience? Wesley down the back.
Did you get any idea of how it sunk or what happened? Because I'm getting an idea of that there's obviously a lot of amphora still in the boat and a lot to the side, which yes, it like went to one side. Did anything come out?
I'm just curious as much as you. You know, actually, you know, this is archaeologists' point of view, I think. So they are the expert people who can just study the 3D CAD model and tell us, okay, what happened? This ship was just sunk because of some damage from out there, or just sunk because of weather or something. I don't know, but I can give you an answer.
Any other questions from the audience? I will just mention that this was co-supervised by Jeremy Green from the Western Australian Museum, and particularly Maritime Archaeology. And Jeremy actually dived on this particular wreck in the late 1960s, and took some of this photography himself, I understand. So it's good to have that long-term connection with this particular story and wreck. So if anyone has got any more photographs of 300 BC wrecks, this is your guide to process the data, right? David Belton sends his apologies too. He's not able to be here. But Jeremy Green is on the YouTube link, and this is a specific request from Jeremy to post a question on the chat. Now at this point there were some millstones there as well, but those haven't been matched in the same way as the amphora have. Could they?
Yes, I think. Of course they could be, but they weren't of interest at this stage. Okay, as this internship this year, so the whole interest was on amphoras. Okay, and particularly millstones were too many. They weren't too many. Okay, and some of them like 10 millstones at the bed of the ship. So they are not going to give too much information about the ship and how it's rigged and so on. So that the main interest was about the amphoras, because they give like this 3D shape and the 3D model. Yes.
Do we know anything about what the amphoras were holding? Obviously not from the photogrammetry, but all of this material was excavated.
We're holding, I'm not sure. I would be sad if they hold gold and if I wasn't there, but
it's probably liquids though, right? Or, you know,
yes, maybe, but I'm not sure.
Yeah. All right. Are there any other questions from the audience?
Is this reusable for any other wrecks if you have to just open
Yes. Yes, exactly. The outcome of this project is not only about this location and this ship. It just gives some insights and gives some ambition for other shipwrecks, especially those ones who may be discovered long time ago with very old photographs and so on. So yes, it gives us like a criteria of how building the 3D models and repeat the same sequence for other projects. Yes.
So this, we believe, is the first time this kind of analysis has been done on a shipwreck. It's particularly surprising because the data has been available since the 1960s. This is 1968, 1969 when the photography was collected, and although they might have thought, oh, we might do some photogrammetry measurements on it, technology has evolved over the past 10, 20 years to allow us to generate 3D models. So these photographs that they captured so meticulously back then are now being able to be processed to generate very accurate surface models of what it looked like, and by combining photo sets of different points in time as the excavation proceeded, we can get lots of other information. So as far as we understand, this is the first time it's been applied to any shipwreck, and potentially it could be applied to many others. And if there's a shipwreck discovered now, then the guidance would be take lots of photographs when it's in various stages of excavation, and that allows a much more accurate analysis of what the site was like. Yeah. All right, any other questions? If not, it's time to move on to the next presentation. So thank you, Hassan. Thank you. All right, Zach, would you mind coming up? Our next presentation is Zachary Webb. And it's Webb with two B's, not one B as I've mistakenly put on here, my apologies. Zach's project is looking at 3D printing of items related to the story of the VOC wreck, the Batavia. It's done also in collaboration with the Western Australian Museum, and it's good to see so many people from the Western Australian Museum here this afternoon, and probably online as well. And I will now pass over to you, Zach.
Thank you.
There we go.
Thank you. So in case you haven't quite looked at the slides yet, my name is Zachary Webb, and this project is called Batavia 3D Printing. There's a little bit of a story I'll run through about the Batavia. I'm not going to go too long because the actual story of the Batavia is incredibly fascinating and intricate, and is also a tragedy. But we'll start with the objective. So the Western Australian Museum is planning a travelling expedition for June of this year with a focus of maritime archaeology, and it seeks to immerse visitors in the actual world of shipwrecks and the secrets that are only discoverable underneath the waves. And the process, or the goal of this project, is to take photogrammetry data that was previously gathered and reconstructed, and convert it through a process to a point where it can be 3D printed into an actual coloured model, which then can be put on display on an exhibition. So now the story of the Dutch vessel, the Batavia. It was constructed in 1628, or the construction was finished in 1628, I should say, and it began its maiden voyage in the exact same year. About 7 and a bit months later, after the ship was taken off course by one of the, I believe the captain of the ship, it ended up striking a reef about 65 kilometres off the coast of Western Australia near Beacon Island, and ended up sinking into the water. The crew, there was about, I think, 327, give or take a couple more, that were on the ship, and after the entire process of everyone getting to the ship, there was a huge massacre that happened after a mutiny was involved, and over 200 people ended up dying over the entire experience, so it's a pretty huge tragedy. Not long after the ship was abandoned, the location of it was pretty much lost to time due to a variety of other losses by the Dutch East Indies Company, the VOC. They had a very ships lost during that time. The exact location was completely gone until it was rediscovered in about 1963. Shortly after 1963, the Western Australian government secured rights to excavate the ship from the, I believe, the Norwegian government, or the Netherlands government, sorry. And in 1972, the Western Australian Museum began its excavations effort after being assigned to it by the Western Australian government. Now,
This project focused on 4 separate pieces of geometry or photogrammetry. The 4 ones that we focused on was the actual wreck site itself back in 1970. So Andrew spoke of a person named Jeremy Green. He was one of the main people, I believe, with Patrick Baker as well, who took thousands and thousands of photos of the shipwreck back in 1962, which is not 1962, 1972, which is an extraordinary feat just in itself because of camera technology back in the day. Nowadays you think you've got an incredibly powerful camera on your phone which can take 1,000 photos, but back in the day it was nothing like that, and so it's quite fascinating that they were able to do that much documentation. So they have the actual wreck itself from 1972 and a couple of years after that during the excavation. On top of that, we also have photogrammetry of the stern of the ship that was recovered from the wreck site in 1972. It has been since excavated and preserved and is now on display at the Fremantle Maritime Museum. On top of that, 137 sandstone blocks were recovered. Another interesting fact about the Batavia, it was carrying a large sandstone portico which was planned to be installed at the Batavia City, and well, when it sunk, it all fell to the bottom, and during excavation they ended up discovering a sandstone brick after sandstone brick, and after they ended up excavating, I think around 30 tons, I believe it was, of sandstone, they reconstructed it and built it into a massive portico, which can also be seen on display at the Geraldton Museum, as well as a replica version at the Museum of Fremantle Museum of Maritime. And in 2019, a freelance photographer, I think David Jackson, he went over to the wreck site long after everything has been excavated and took a variety of photographs to reconstruct photogrammetry, which was also done by the Hive. And these are the models that we currently have. So in the top left, we have the 1970 wreck site. This is all of the photogrammetry as we got at the very start of the project. Right underneath that, we have the wreck site from 2019, taken by David Jackson. Right in the middle, we have the reconstructed hull, which is currently viewable in the Fremantle Maritime Museum. And we also have, I believe this is the replica one, the photogrammetry of the replica one, not the one from Geraldton, but they are pretty much identical. And the exact sizes, I'm not quite sure, but these are quite large objects, as much as they might not be to it on the screen. And the project timeline kind of went out like this. During the very start of the project, we researched possible outcomes of the project, what we wanted to actually print and what we actually wanted to work on. I then went through the process of reviewing the photogrammetry and resourcing and figuring out how we were actually going to get the models printed. After that, we went on to develop the 3D models, select printing deliverables, so which ones we were actually going to finalize and select, and then modifying it, because there's a lot of small amount of tweaking that was required to do to actually get them to a printable state. And we'll be hopefully printing or sending them off to print in the next coming weeks or months before the travelling expedition in June. So the software that I ended up using, there was a huge variety of software, also other ones including like Microsoft Word and PowerPoint and Excel, but that's kind of a given, most people use those nowadays. The main 5 focused software was Autodesk Maya and ZBrush. These 2 softwares were used for model retopology as well as for modification and projection. The next 2 programs, which were more focused on textures and reconstructing textures, were Substance Painter and Adobe Photoshop. And then finally, for the final modifications to models to get them to a printable state, it was all done in Blender. Now, this is the original starting point. So one problem that you kind of have with photogrammetry is that it's a bunch of photos that have all been taken, and then you feed it into a specialized program which then judges depth from the photos and reconstructs a model. It does not do a really clean job of doing it. It's very messy. You can see in the photo on the right, or on the left, you can see the current photogrammetry model of how it was. And on the right, you can see the wireframe, which the wireframe just simply shows all of the edges of the polygons, and it's incredibly messy. And while it does work, it gives you the visually pleasing result, it's incredibly inefficient and not that great to continue working on, so it needs to be redone. So the first step was retopology. It was taking the original photogrammetry and creating a brand new mesh. On top of the original photogrammetry, one problem that you do have when you're taking photographs of object is if you don't get the entire model encapsulated in the photographs, they end up being non-watertight and kind of flat models. So there is actually no structure to the original photogrammetry. It's just basically a kind of paper wall. So there's no inside. If you try to hold water into it, it would hold nothing. And so the first step to get it to a printable state is it needs to be a watertight model. And so that's what was done at the very first. Reminder that this is also done for pretty much most of the models. The portico was the one that required the most amount of work, is the most one that you can actually see the work, so I'm using this as an example. After the retopology, it came to projection. So with projection, you take the original photogrammetry and you give it to the retopologized one, and then based on proximity from the two models, you kind of paint or push the textures from the photogrammetry model onto the new one. And so you can see that with the retopologized one, the right, after it's had textures added on, there's a lot of white areas where there was previously no textures. So after that, we move on to texture reconstruction. So in texture reconstruction, it's just simply taking previous texture data and then extending it and using content-aware tools and brushes to kind of reconstruct it completely from scratch. It's a bit of a tedious process, but when you put enough time, enough effort, it ends up creating really good results. And the final process was, creating the final modifications for printing. So when it comes to printing, especially when you're printing in color and the material that we're using, it can get very expensive. And if you don't optimize it properly, you can end up having a print that's about 20, 30 centimeters tall and end up costing multiple thousands of dollars. So to reduce prints, one method that we were exploring, which we explored for most models, but this one is the one where it really came out, was hollowing the inside of the model. And so creating a hollow version, as well as following other hard restrictions and guidelines for the printing software or the printing service, created multiple different versions of it. And it can also be seen, I believe, in this one. So at the end of the project, we ended up coming to two final print files, which were supplied to the museum. The first one is the sandstone portico, which is on the left. It's completely ready to be sent off, and we're hoping to get that sent off soon. The next one is the reconstructed Batavia hull. So with this one, we had to do more than just simply throw it in and slice into three pieces. There was a large amount of supporting structures. If you actually go and visit it in the museum, it has large pieces of metals and spokes and wires connecting to a wall to simply hold it together. And since that wasn't really a part of the initial wreck, most of it, pretty much all of it, had to be removed. There's some that you can't remove, which you can see at the very edge of the stand, but that's okay. This model specifically was cut into three individual pieces to maximize the print size, or to use up pretty much all of the budget that we had left and create the most visible print. So the actual print size when this gets done, if it's assuming that it gets done, will be about 57 centimeters long, about 30 centimeters tall, and about 20 centimeters wide. So pretty reasonable size, and it will likely look very good once it's constructed. Additionally, the 1970s rec site was worked on. We explored a variety of different print options for the site, but simply print size was a bit of a worry, and texture detail coming out, so we ended up leaving this in the back burner and working on the other models in the end of it. Additionally, the 2019 rec site was retopologized to create a more cleaner version which could be used in digital programs like Unity and for other experiences in the future. And thank you. Before I finish, I'd like to make a few acknowledgements. Hopefully I can remember them all off my head. Andrew Wood, I would like to thank you for access to the Hive and making sure this happens. Rachel Hughes, I'd like to thank you as well. Everyone on behalf of the Museum of Western Australia, as well as the Fremantle Maritime Museum, I'd like to thank Jeremy Green and Patrick Baker for their work on making this actually possible, because they were the ones that went down and excavated and actually worked on this back in the 1960s. Yes. You too, Carly, thank you very much. Wesley Lamont, Carly Tillett, Daniel Adams, yes. And then there's also David Jackson, I believe his name, which is the photographer that took all the photographs in 2019. And thank you for listening to my presentation. And Jonathan Ply, yes.
Primary supervisor, don't forget the primary supervisor.
Yes. He couldn't be here today, I hope he's online. Thank you.
Any questions? I'll do a start. How much stuff have you had 3D printed before?
My personal 3D printing experience?
Yeah.
I've messed around a few of it, mostly just printing small little kind of desktop objects, but I haven't really personally experienced or went into printing large or kind of obscure or intricate pieces like the Batavia portico or the hull.
Yeah. This is a bit of a leading question. Generally, the students haven't had any experience with the particular topic they're working in, so these projects are really a good opportunity to get their teeth into an interesting and innovative and project that has lots of research outcome potential. There was a question from Hassan in the back.
Yes.
What usually the material which is used to print 3D print any object?
Yeah, so there was a variety of print materials selectable. It was pretty much decided at the very start of the project that we'd like to get it printed in colour, and that generally raises a lot of questions for some people if you've ever actually looked into 3D printing or just basic 3D printing using modern day printers. They mostly are done in just single colour plastic, so when it comes to colour it's a bit confusing. But the process or the material that we're using for this is sandstone, and what they end up doing, they have a bed of sand where they have a nozzle come through and spray certain inks to combine together to one colour, and they put a layer of glue and they add another layer of sand and keep doing that, and they reconstruct it kind of vertically in a massive bed of sand, and then they end up pulling it out of the sand, giving it a coat of resin and kind of strengthening materials and glues, and then you end up having a full colour 3D print.
It's available to have a color 3D model.
Yeah. Yeah, it has full colour. Normally with most 3D printing solutions nowadays, at least one's available for hobbyists, they're just single colour plastic. I think it's called FDM printing, where they kind of just print a layer by layer by layer until they create the entire thing.
Fused deposition modelling.
Yes, there you go. The more
We've got to be
official
careful.
name.
Hassan wants to 3D print the Kyrenia now. I can just see it.
He's just quaking in his chair. He wants to just let him at it. Is there anyone else that would like to ask a question?
Jill.
How much does it cost to print something like the Batavia?
The portico. I believe I believe the initial quote, it's a bit tricky because it's a US-based company, so you've got to do all the conversions, and there's additional shipping costs and materials. I believe the original price was around $1,200 before it was hollowed out, and then the hollowing out process reduced it to about $500 US, and from there, when you convert it, includes shipping and the resin coat which they apply to enhance the colour and increase the structural integrity of the print. It comes out to, I think, around $760 for the portico, and that's
for the one that's 50 centimetres high?
316 millimetres and about 25 millimetres wide, so or 250 millimetres wide.
Or for those who like the old measures, about a foot.
Yes. And then
This is really old, right?
Yes. And then just for the leading question is how much is the Batavia hull going to cost to print? Well, after it was separated, there's still we could still technically reduce it a bit further because the piece on the very right, the larger piece, can be hollowed out partially because there's a large amount of just full area which can be just hollowed out. This one, when you include all the pieces, the left piece I believe costs about just under $200 to print. The middle piece costs, I think, around $400, and the piece on the right costs about $800 to $1,000 to print. And when you convert that out and you include all the resin coats and shipping, it comes to about, I think it was about $2,500. But because Hive is a fantastic educational facility, we do get a discount on it. So all up, if you can include both the prints, it comes to about $2,700 to $2,800.
Yeah. And it's all dependent upon the size. Each 3D printer technology has a different costing and a different capability. And as you increase in size, the volume increases at a
pretty much exponential rate.
It's not an exponential rate, but it's it is a function. It's a sort of a cube, perhaps, of the. Well, it is exponential, then, isn't it?
Yeah.
Yes, that price could rise incredibly if you enter in the wrong number. Maybe an extra zero would probably add an extra 2 zeros to the price. A question from Zach. Sorry, from Hassan.
So here you mentioned that the model could be separated into many parts, and then you can collect all of them after 3D printing.
Yeah.
So what kind of aspects you should consider during the design of the 3D printing, so you don't end up, by having a certain part which is really hard to be combined or welded to the other parts?
So there still needs to be a little bit more exploration in how we are combining them together, and it will likely be included in the report that come out of it. But essentially, the larger the print, the easier it becomes to print it, because when you have a really small print, you'll have issues of thickness because there's a very tight or really restrict thickness guide for printing sandstone, and if it's not beyond that, then you'll just have troubles where you'll be going around and smoothing up this edge in the model, smoothing up this edge just to get it to be accepted into the program. And the only issue is that when you get to a very, very large model is you have to separate it into more and more parts. So this model is actually, I've estimated it to be about a 1/15th scale of the original shipwreck. I looked at a variety of different scales. There was 1/20th scale, which could be printed as one whole piece. 1/17.5 scale, which could be printed in 2 pieces. The 15th scale, which is in 3 pieces, and I believe when you went up to the 1/10th scale, it needed to be separated into 9 individual pieces to print. So it does get very confusing.
And that's due to the bed size.
Yes.
The maximum volume you can print in any one go.
Yeah, and so when you start getting it to a lot bigger, it starts being like, well, now this one piece that could fit in one print size now needs to be cut to 2 pieces, and this piece needs to be cut into 3, and it becomes a real headache to work with, as well as expensive. I believe the initial quotes for the 1/10th scale was around $5,000 US, which is very expensive. And combining them, we'll still be doing a little bit more exploration. I'll be hanging on to help them do that, and we'll put up in the report. And
well, thank you very much. Yeah, unfortunately we're going to have to move along because you've run out of time. That was a really good explanation to the question, but we're running out of time and we've got to move on to the next one. So thank you very much, Zach.
Thank you. Oh, yeah, don't want to walk off with that.
Yeah, we'll hear all the good thing he's got to say about the next presentation rather than the actual presentation. So Ayush, if you could join us up the front here. Let's go to the, here we go. I'll actually bring up Ayush's presentation this time. So Ayush is doing a Bachelor of Science degree in Actuarial Science. What that degree has got to do with the interior of the Earth? Good question, and Ayush will explain all of that. Probably not much, but we like to have students explore different areas. So so his project is supervised by Luke. What's Luke's last name? What he said. And I will now let Ayush.
Thank you.
Describe.
Perfect. Good afternoon, everyone. Let me try and raise this up a little bit. There we go, that's better. Good afternoon, everyone. My name is Ayush, and I'm currently heading into 3rd year of Actuarial Science. So the main reason that I was attracted to this project was essentially due to the fact that I was keen to investigate the Earth's inner structures, understand its mechanics. Furthermore, I was really interested in understanding how its implication is to real life, such as like earthquakes and volcanoes. And lastly, I want to expand my coding knowledge, how to like implement ideas and how they're used in projects so that can be implemented in real life. So before I begin, I would like to just give a brief background on the earth science and the stuff of the little things here and there that are essential for this project. Essentially, as we all know, that the earth is made up of multiple different layers, as figure 1 shows. It consists of the crust, the mantle, the outer core, the inner core. The composition of these layers itself are vastly vary, and to investigate this, a process is used, which is called seismic tomography. Now, what is tomography? Tomography itself is just using sectioning, which is just cutting it up through any uses of penetrating waves. Now, in earth science specifically, you use seismic waves, and seismic waves are formed through explosions or earthquakes. So essentially what is done is that you just, the data set itself is you just shoot it straight through, and then you can see the seismic velocities. Now, in the general aspect, or the general view behind it, is essentially that all seismic waves should travel at the same speed across the same line if the Earth itself was homogeneous. That is that it is chemically similar. However, we all know that it's quite mysterious, it's complex in nature due to its multiple structures, its thermal variation. So that causes velocity anomalies, essentially where the seismic velocity travels faster or slower depending on the medium itself which is going through. So in general overview, it is that the deeper they go into below the Earth's surface, the faster the seismic velocity is. That's basically due to the fact that it gets hotter and hotter. Now, if large low shear velocity provinces, which are LLSVPs, were essentially found and discovered through seismic tomography, what they are essentially is just two colossal blobs sitting on the Earth's mantle. So you can see on the second figure here, you've got the two red images that are just sitting across the Earth's inner mantle. Now, the reason that they're quite important is that they affect a lot of the Earth's properties. They're thought, to affect multiple of the Earth's properties. These include such as like magnetism and especially volcano interaction. This then leads me to mantle plumes, which is the final figure here, which is essentially just hot rock, which is just convected to the top of the surface. As you can see, the red part here on the last figure, that it's convected to the top of the surface, and it's thought to be the cause of volcanic centers. So, in this project itself, there were two main prior models that were discussed. The first one on the left here is the Curtin model. The Curtin model itself was quite, if you can look at it, if you see it, it's quite interactive, it's quite visual, and it shows the LLSVPs. However, it is not descriptive. It lacks those sort of descriptive properties that are needed, that are presented as well in my suggested model. Secondly, the image on the right here is called the submarine model. Essentially, it's just this model itself is just the opposite of the Curtin model. It lacks the visual properties. It's not very pretty. It's not 3D as well, but it is quite in depth. But it gets to the point where it's just too much information, and for starting users, it becomes too not user friendly. So this is leads me to my own new and better model, which is shown on the right here. And the main reason that I'm presenting this model is because it has those visual features. Furthermore, you can actually section it up, you can slice it up, you can play around with it, which some of the other models can't. So it just becomes a better and overall model that can be used. So in this project itself, I went through a series of 4 steps. I extracted the data set, which was just a bunch of CSV files. Went through a bit of coordinate system conversion just to plot into a sphere. After that, I visualized that point cloud, which is point clouds are essentially just X, Y, Z coordinates on a 3D space, and voxelated it. Voxelating itself is just making little Lego-like cubes instead of having the points itself. After making that final model, I made the user interface, which allowed the slider widget, the slicing widget, and the checkbox widget just to make it a bit easier and allows for a deeper analysis. And finally, I just polished it up by attaching a color map, texture mapping, and just playing around with opacity so that becomes better user-friendly. So the first step was the data files. As you can see on the second image here, there are multiple CSV files ranging from 50 kilometers to 2850 below the Earth's surface. They contain 4 columns. They're geodetic coordinate system, it's called the longitude, latitude, the seismic velocity, and the depth. There's a bunch of them, so essentially I just combined them up and made them into one big file. But before I did that, I went through a series of conversions to convert that geodetic coordinate system to Cartesian so that you can actually plot it on the sphere itself. So from there, I convert it through the equation, sorry, on the first figure, just a bunch of simple equations that are quite actually easy to understand, and it gave me x, y, z coordinates, and the a value, which itself was just the seismic velocity. If you look at, there's a difference in a value, because it goes from negative to positive. That's just to make it easier for us, just to only have positive numbers, so it's easier to plot and easier to visualize. So this is the first visualization of the point cloud. As you can see on the outside and the inside when I zoom in, it is color mapped across with the seismic velocity. As you can see as well, it is quite interactive, so you can rotate it, zoom in, zoom out, whatever you want. It was a good starting step. So from there, we went through, I went through, a process of voxel modeling. Now, essentially, like I explained before, voxel modeling is just making little Lego-like cubes of it. And the image on the right below the cube, explains the whole process. Essentially, you just have the image and you just convert it into a bunch of cubes. You might be asking, why do we actually need this? Why is it important? And it serves three main advantages in visualization. So firstly, it provides more precise modeling, and that's because it allows for, it mimics actual data particles. So that allows for just a better visualization. Secondly, it allows for deeper simulation techniques. All that stuff is never been done before, and it's really good to just get to deeper visualization. And lastly, it's efficient to use. It's the quickest way to visualize volumetric data sets, which is my own, and just becomes easy to visualize, and also allows a better modeling. So this was the actual voxelated point cloud. So you can see some of the outside, you can see some of the actual cubes itself. It's a similar image, but instead of having the points now, sorry, I might have zoomed in too much. It's got the cubes itself now instead of the points. So from there, I then, even though that model, it is quite good, it lacks some properties. So firstly, there's no locations on there, and for someone who's like a beginner, they wouldn't know where to start, they wouldn't know where everything is. So I added the locations of key hotspots. And then from there, I also added in a slider widget, and the slider widget itself is such that it masks any voxels so whatever the user picks, that's the only voxels that are shown. And lastly, I added slicing, just all these features so that when it's used in future research, or if anyone wants to really use it in the future, it becomes quite easier to understand, and you can get better contrast and comparisons. So adding the locations itself was quite simple. Firstly, it was just going through a series of steps of just converting the coordinate systems. That was, once again, like I explained before, was exact same process. It's quite simple to do. And the slider widget here, so firstly you can just see I've attached the locations across it. The slider widget, like I said before, it creates a threshold, and any values above that threshold will not be shown. And so obviously what I've shown below the threshold is visualized. So if you look here, the original image, I've set the seismic velocity, at 7.49, and now I've set it at 9.03. And if you look at the color scheme at the bottom here, 9.03, any values above that will not be displayed on that image. So just by having these user interface constructions, it really helps deeper the analysis, and it can be really useful for a lot further research. So from there, I then made a slicing widget, which you can see is just simply just a box around it, and wherever the user chooses to rotate the box and move that little arrow, that's pointing in, you can just slice the model anywhere you want. You can see the cross sections, so you start to see the actual seismic velocity inside the sphere, and it just becomes, once again, for further research, it is quite important for this to happen. So lastly, after I made that sphere itself, another thing that we thought was important would be having a texture map over it. Texture mapping essentially is just getting any image you want and just wrapping it around. The image that we chose was just a highlighted continents texture map. The reason we chose a continents texture map was just simply due to the fact that now you can start analyzing continents, the continents by continents, and not only that, you've got the locations itself. So from there, you get, instead of just having just the locations, the contents will provide a better analysis. So the way that this was done through Blender, which is just another software. Essentially, it was just making a UV sphere, which is just, if you look at the first image, it's just a sphere with rings and segments in it. There's nothing special about it. All we did was just make it, and just made the same radius as the Earth, which is 6,371 kilometers. So then after we made that sphere, we simultaneously plotted them on top of each other so that the texture map is seen on the outside. And you can see that on the final image on the top right here, that you can start to see some of the continents that are coming through. Lastly, that model itself was quite good, but there was some changes that I had to do. So firstly, I tweaked the opacity because if you saw in my previous images, it wasn't see-through, so I decreased the opacity such that you can start to see the inner structures. That's essentially what we really want to see anyway, so we have to, I dropped the opacity by like 0.2 and helped me really start to visualize some of the inner structures. And the second thing as well is the color map. Color maps are surprisingly really important. I wasn't actually sure about that, and until Kylie explained to me what they have a lot of significant meaning. Essentially, there's 4 types of subclasses. There's a sequential, there's diverging, there's cyclic, and there's qualitative. Qualitatives are for data sets that are random in structure. So you can see that on the bottom here, that this data, that the color scheme is just quite all over the place. That's just how. It matches the random structure. Cyclic itself is just that when you've got endpoints, so normally with some sort of spheres at the top and the end, like the North and South Pole, you'd want those to be colored differently. Diverging is that where you have a medical critical value. Essentially, it's just used for anything that is like a rectangle, is you want to pinpoint something in the middle. And sequential, which is, in my opinion, what I perceive to be data sets that have structure. And if you look at the second box, from the top. The one that I chose was magma, which is 4th from the bottom. There is no special reason why. I just thought it matched my data set well, and it allowed a diverse range of colors so that you can really perceive and actually really visualize what's going on. So this is my final product. As you can see here, you've got the seismic velocity at the top. That's a slider widget. You can manipulate that as you wish. You've also got the continents texture map across over there and the slicing widget so that you can cut it wherever you need. I've also just put in a simple checkbox widget just so that you can turn on and off the texture map, just because I feel like when you're actually interacting with the sphere itself, it can be a bit harsh sometimes to just get around and understand what's going on when there's a massive texture map across over it. That was my final product. So for future work itself, the actual rendering speed of the model is not super slow. It is slightly slower than I expected it to be. So we discussed through a better visualization experience through ParaView, which is just another software that strictly does visualization. This project, was done through Python, just Python only. So going through ParaView would be a good next step. Furthermore, if I just go back, on here, there's only one slider widget. So you can only control one of the thresholds. It would be good to have multiple of those so you can start really getting in an upper bound, a lower bound, and just like even if you have like 5 sliders that you can play around with, it just becomes a lot. You can start getting a lot better visualization, and not only that, but you can compare and contrast a lot more aspects of the model. And lastly, I would love to see some of these models compared through time series, essentially just having data sets from 10 years ago, 20 years ago, and seeing how the structures of the are changing throughout time, seeing what's actually going on. That would be a really good next step. Lastly, I'd like to thank Luke Dissett, my primary supervisor, who helped me with the guidance throughout this project, and Kylie especially for her expertise in coding. She really assisted me through there, and Curtin HIVE for providing me with an amazing opportunity and their general support. Thank you so much for listening.
Are there any questions for Ayush? No? All right, I'll ask the first one. So all of your visualizations were generated from within Python?
Yep.
Did you consider using Unity for some of the visualizations?
Yeah. So me and Kylie had discussed possibly implementing Unity as well in there. It's just the lack of time was one of the reasons, and I wasn't actually. I hadn't done Unity before, so it was quite. I didn't want to make it too complicated as it could be. Yeah.
Yep. There's only 10 weeks.
10 weeks, yeah. So it can be a bit hectic. Yeah.
That's it. Any questions from the audience? So how is the data originally collected?
So it's collected through simulations that are done below the Earth's surface, and you just extract those through the it's just like a machine that just runs through. And you just get the seismic velocity from there. Yeah.
Mm-hmm. So is there any experimental data that goes into these models?
I'm not actually too sure, but I was when I was discussing with my primary supervisor, I asked the same question, and from memory, he said that it was just the simulation data that they had collected. Yeah.
Mm-hmm. So with your visualisation, are you actually? I think you showed the slider, and you are able to move it.
Yeah. So all the interactive experience, it can be done through the model. You can rotate it, translate it, zoom in, zoom out. And you can, there is also the slider widgets and the multiple other widgets as well that allow for anything that can be toggled on and off, and yeah.
Okay. Any other questions? Okay, so at that point I think we'll switch into the demonstration session. So thank you very much. So
no problem.
Please join me. All right, so on the cylinder display we will have Shuchi talking about her exhibition plan, and you can see the wonderful panoramas showing Fremantle from various locations, and she'll even be able to show you her favourite one. On the wedge display we've got Hassan's 3D models of Kyrenia, and you can even ask him how soon he wants it 3D printed. Zach is in the dome area, and I can see a 3D model of the Batavia Rex site from 2009 there on the looking glass display. That's a new display we actually just purchased before Christmas. Allows you to see a three-dimensional image of the item you've got within the display there, and he'll also show you some of the other stuff hopefully on the big screen. And then Ayush will show you his code running on Python. It's nothing to do with a slithering serpent, it's just a name of a piece of programming language. Who was it mentioned Python earlier? I think it was Josh who mentioned Python earlier in combination with C++. But yeah, it's just a programming language. A lot of kids in primary school are learning Python now, so if you don't know any Python, you should feel ashamed of yourself. Very popular programming language. And so Ayush will be showing his project here on the tile display. We'll be having a sort of a break at 2:50, and then everything is restarting again at 3:10 p.m. So I'd like to thank all of the presenters, all the supervisors, and I actually haven't put much of a call out to the Hive team so far, so thank you, Wesley. Wave your hand. Thank you, Daniel. Wave your hand so everyone knows who you are. Thank you, Carly, hiding over in this corner. She's been bashing away at the keyboard, trying to get various demonstrations ready for your viewing. And yeah, so thank you for the team assisting the students in all manner of different ways. Our goal here is to support the projects, support the students, and whenever the students come up with a difficult problem, we're immediately there saying, I think this might work. So yes, and then we can try to help them to help themselves. All right, so thanks again, and please enjoy the presentations, and ask lots of questions. we go. All right. Well, welcome everyone to the 4th session of the Hive Summer Internship Showcase. In this particular session, which is the last session of the day, is 3 presentations. Chloe Hall, Scott Bell and Joshua Quizera. Again, we've got presentations from all sorts of weird and wonderful different areas. After these presentations, we'll have a demonstration again on the different screens. But at this point, I think I should quickly introduce Chloe Hall, and I'll just start her presentation here. Where's my mouse? There it is. And I think Chloe almost gets the prize for the longest title. Spike protein of SARS-CoV-2 and its interactions with antibodies and receptors and the role of mutations. And I'd like to thank her supervisors for proposing and supervising the project. So we got Ricardo over here, Chris Malachek, and Lena. I'm sorry, I was trying to remember your name. So thank you for being here. And Chloe is doing a Bachelor of Science in Chemistry and Biochemistry, is that right? Very good. So I'll pass on to you. I might just tuck that into your t-shirt at the top here. There we go.
Thank you. Hello everyone, my name's Chloe Hall and I did the spike protein of SARS-CoV and its interactions with antibodies and receptors and the role of mutations. So essentially, my project was to visualize the spike protein and its interactions with 2 different receptors and an antibody. The 2 receptors were the ACE2 and the DPP4 receptor, and the antibody was the CV07250. So the expected outcomes were, from a teaching and learning perspective, were to give a scientifically sound and meaningful, informative model of the spike protein and give access to the general public. Hopefully this will reduce misinformation, as there is a lot on social media platforms these days. So hopefully people with access to this will actually understand the virus a bit more, and with the mutations and the primary receptors and other things that are going on with the virus. From a scientific perspective, the mutant models that were created remain stable throughout the simulation, so hopefully through more rigorous testing and analysing through GROMACS and PyMol and stuff like that, we can get a better understanding of the interactions of the mutant in comparison to the original RBD. So just give you a bit of background on the things I just talked about before. So the spike protein is made up of 2 subunits, S1 and S2. The focus for this project was the S1 subunit because it homes the RBD, which is responsible for its interactions with different receptors, like the ACE2 and antibodies, and is also responsible for recognition and binding to the host receptors. It's also covered in complex carbohydrates, which constitute for its cloaking and camouflage to evade the immune system. It also has an open and closed state. So in open state is when it recognizes that the ACE2 receptor is close by and it binds to it. And when it's in its closed state, it can't recognize any receptor that it wants to bind to. So it is basically inert and evading the immune system yet again. We also have the host receptors, the ACE2 host receptor, which is responsible for regulating a hormone called the ANG2. This controls inflammation and blood pressure, and an overproduction of ANG2 hormone can actually lead to acute respiratory distress syndrome, which is the leading cause of death synonymous with SARS-CoV-2. So it's obviously important to recognize and determine the binding mechanisms and thus the interactions to manufacture therapeutics that could competitively bind and inhibit the interactions that it has with its primary receptor. So we have the DPP4 receptor as well, which is actually just a proposed receptor due to a few reasons, such as people with diabetes, being hospitalized with more severe symptoms, high mortality rate, and the correlation of inhibiting this receptor and improved clinical outcome of patients with SARS. So obviously if something is observed to have an improved clinical outcome, you would want to focus and think about strategies toward maybe preventative therapeutic solutions involving this receptor, all that stuff. So we also have a background on antibodies. So antibodies are the body's natural neutralizing agent. So scientists elucidate structures and interactions to monitor how antibodies competitively bind to RBDs and neutralize so the RBD is a spike protein, just reminding again. The extractions of these antibodies are important to find therapeutic solutions and guiding the vaccine design thing. So we have the mutations lastly, which are important to monitor as they change the way that the receptor binding domain actually binds to the ACE2 receptor and how antibodies can interact with the RBD as well and then inhibit it. So sometimes the mutations experienced by the RBD result in a decreasing affinity with the antibodies and an increased affinity with the ACE2 receptors, which aren't good for us. So why these particular receptors? Obviously ACE2 is the primary host receptor, TPP4 is a proposed, and antibodies are the body's natural neutralizing agent and one of the leading kind of studies that are used when designing vaccines and therapeutic solutions. So the workflow was we chose what host receptors and antibodies were important, especially when regarding where the RBD is interacting. There are so many receptors in the body, so obviously we want to choose the most important ones that actually interact with the RBD. So the next step was obtaining the PDV molecule files from the protein data bank and modifying these protein structures and coordinates using PyMol. Then visualize a static spike protein with host receptors and antibodies in MDV. And then there was two kind of paths from here. We created the mutant spike protein and then in Discovery Studios and then produced a molecular dynamics simulation. And then we produced a molecular dynamics simulation of the RBD and ACE2 receptor using GROMACS. And then finally into MDV for visualization. So how do we do the static structure? So we had 4 PDB structures, one for the spike protein, one for the ACE2, one for the DPP4, and one for the antibody. And these were loaded into PyMol. So PDB is basically a database filled with structures of large biological molecules. And these have been empirically determined using different techniques such as X-ray crystallography and NMR spectroscopy, and a few more. And PyMol is software compatible with these PDB files that allows for easy modification of biological system and coordinate changes of the systems. So for the spike protein and all of the PDB files, they underwent a series of modifications to the chains and structure files to just remove any unnecessary molecules that might interfere with GROMACS and all those kind of things. And then altered the coordinates of all the things because the spike protein was basically the reference structure and everything else was in some other place in virtual 3D space, so we had to move them and change the coordinates so they're all sitting next to the spike protein. And then, so just a little bit about molecular dynamics. It's a simulative technique that allows viewers to visually analyze the movement of atoms, and it can, so you can observe the evolution of a biological system over a small time scale. So it uses 3 main components: force fields, energy minimization, and equilibration. These are used to kind of emulate a real-life scenario for experiments. Obviously, this is a virtual machine, so you want to make it as close to the real life as possible. So force fields estimate the energies associated with bonding, bonding and non-bonding. And then energy minimization basically just finds the arrangement of atoms in space where there's the lowest given energy and it's relaxed. So hopefully finding a structure that isn't too unrealistic if you put it into real life and would be very unlikely to exist. And then equilibration just fits the virtual system to the environment and real life experimental conditions like atmospheric pressure and room temperature or biological temperature. So how did I kind of incorporate molecular dynamics? So the RBDs that were made in the static structure were kind of exported as systems with their respective receptors and antibodies. and then they were subjected to GROMACS using Magnus supercomputer. And then obviously all the MD kind of components that I talked about in the previous slide were incorporated into this, and then I processed on VMD just to correct the coordinates because they move around sometimes when using GROMACS, and then I extracted the trajectories and isolated them from their solvents, and then smoothed out the trajectories just to make it a little bit more visually appealing. And then for the mutant, in Discovery Studios, I changed the residues. I gathered empirical data and then changed the residues accordingly. And then they were minimized, and then the mutants were then subjected to GROMACS using Magnus again. And then the same post-processing kind of thing went on with correcting coordinates, extracting trajectories, and smoothing out trajectory. And then finally, we have all the 7 components ready for MDV, so we can visualize the interactions at the interface. So the secondary structures were all enabled. Having primary structures available was just a bit too much, and it kind of distracts from the interacting surface. So just did the amino acids present for the interacting amino acids that I could gather from research articles and stuff like that. And the final structure looks a little bit like this, or looks like this. And then last, oh my gosh. Carly, you did not play the version. Well, that's a bit awkward. Just like to acknowledge and thank all of my supervisors, Chris, Lena, and Ricardo sitting right here, and the Hive staff for helping me whenever I needed help. So, thank you very much.
Are there any questions? I have one. It's a Dorothy Dixer. What's the difference between VMD and MDV?
A lot. I mean, they're the same kind of, they're used for the same kind of visualization type thing, but one's made on Unity and one's, I think, made from a different type of software.
Yeah, so I think it's, which one is MDV?
This one's MDV.
It's actually developed here at the Hive.
Yep.
Michael Wybrands is the main developer of that, and that is what allows us to display it on the various displays, including the cylinder display here. So yes, they have very similar capability, but VMD can't display on this, so MDV was developed for that.
Yep.
Any other questions from the audience?
Awesome.
So in the visualization, do we see a docking maneuver, perhaps?
No,
Not really? Yeah.
Yes, no. Just interaction.
Sorry?
Just interaction.
Just interaction.
Yeah. It was
Interaction of what?
just the amino acids from the RBD and the ACE2 receptor, ones that I could gather from different research articles anyway. Yeah.
And what percentage of the overall coronavirus is that little part, do you think? 1%?
Yeah, it's not much at all. It's very small.
But it's a very important part, isn't it?
Yes, extremely important, yeah.
So I've been watching it being experimented with in the last couple of weeks, and it's pretty amazing to see. So you won't be able to miss it in the room, but yeah, make sure you come and put the 3D glasses on and see it when it's going. Hopefully it doesn't restart in the middle of yeah. Any questions from the floor? We've got 5 minutes to fill. There has to be some questions. Now, how important is it to understand these receptors?
Well, maybe from a scientific point of view, it's more important if you're doing research, but I guess from a layman or just a person in the general public point of view, it can help reduce misinformation, because I know there's a lot of crazy kind of rumors about mutations and
The receptors are all about the vaccine response, isn't it? Is that correct?
Yes. Well, no, the spike protein is what we
Oh, the spike protein, okay.
which binds to it.
Right. And of course, now with no news on Facebook, you know,
Yeah. Oh, yeah, that might actually.
there'll only be misinformation, of course.
Yeah, that might kick that one in the. Yeah, of course.
Any other questions on the floor yet? So it's a very deep and technical area, but like I said, I guarantee you it's very interesting once we get it up on screen. What's it? Has it informed you of anything, Ricardo, as yet?
Well, one of the receptors that is modeled here, we model the interaction with the spike protein because there is no experimentally determined structure. So we work on predicting how it will bind to the spike protein. And so while it does bind, it doesn't appear to bind very strongly. So there's still debate as to whether it has any disease implication as far as COVID-19 is concerned. But it's, so from that point of view, the visualization, of course, is a very attractive way of seeing how these different interactions compare with. But more generally, I think one of the main goals is to be able to say it yourself, bring to everyone the opportunity to see this very important part of the virus in action, in 3D, in an immersive manner, and see, for example, what are how do the interactions with the receptor look like? Where are these mutations, for example, because there was just the one that you investigated. For example, what are these mutations that we all hear about in the media? Where are they? What is the likely impact that they have on the structure of the spike protein? And I think that makes it more realistic, and it needs that people have a clear idea of what we mean when we talk about this, the spike protein and mutations and the receptors. I think it's all very vague unless you can actually visualize it like we do. So I think that's one of the biggest advantages of being able to do it in 3D. And of course the simulations that we do, we have a full animation of the structure and interactions of the various molecules. So it's, nothing replaces being able to have this immersive experience with it.
Yep. And for people's reference, we've actually just completed an upgrade of both the cylinder and the dome projection systems. So we're now using 4K projectors, laser light engines, much brighter than we had before. So the images are looking so much better as it finishes restarting than our previous projection system, and it just makes the image even more punchier than it was before. Still obviously in 3D, we've got the 3D glasses on it, and these molecular dynamics visualizations are some of the most impressive visuals we've shown on the screen, and very much forward to seeing Chloe's work on the screen. There's a question.
Yep, from Michael White-Rose. In the first few weeks, you had some issues early on showing on NDB. How did you resolve this?
I separated, so there was, so on the kind of spike protein, there are these molecules called NAGs, and they're not actually a part of the structure, they're just kind of sitting on the outside. So in MDV, there was, it was reading those NAGs as part of the structure, so we just kind of separated the components and separated them into components, and then it didn't read it as the structure anymore, and so the secondary structure popped up and it wasn't grey and all weird anymore. Yeah, that's how we fixed it.
Very good. So Michael's one of the developers of MDV, of course. He's obviously got burning ears at the moment.
He said thank you.
Thanks, Michael.
Thank you.
All right, well, please join me in thanking Chloe.
Yeah, thanks everybody.
All right, our next presenter is Scott Bell, who will be visualising 21st century boulevards. Scott is studying a Bachelor of Arts in animation and game design, so very, very applicable to this particular project. and in particular I was looking at the topic of trackless trams, and at this point I think I will pass on to Scott and I will mic you up, and there's your pointer.
Thank you very much. Yes, my name's Scott Bell, and I'm working on the Visualising 21st Century Boulevards project. It's been a very interesting project thus far. Much has been learned, and it's been an interesting melding of many different workflows and pipelines. But to begin, I'd just like to quickly go over how I've laid this out. To begin with, the objectives, what the project itself was looking to do, the methodology of how I went about doing that, some differences of that methodology to alternate methods, the results, a small conclusion, some thoughts on the future of the project and the pipeline, my acknowledgements, and then we'll end with some questions. To begin with the objectives, boiling down many of the objectives that I was given, I wanted to focus on and showing how trackless trams were good for urban regeneration, how these mid-tier transit options would be very applicable to modern boulevards and urban design, and how useful they are. Trackless trams being a form of transport that are similar to trains but require no rail and can be installed on ordinary roads almost anywhere. They're energy efficient and more energy and environmentally friendly than buses in some regards. The next part was the design of the boulevard itself, taking inspiration from older boulevards, for example 15th to 16th century Parisian boulevards, where the focus was on people more so than vehicles. Large livable spaces where you could walk the dog, have a picnic, or any number of things, but it also didn't forget that vehicles were a thing, of course back then more carts and horses. We wanted to take that idea and merge it with 21st century technology, such as solar power, electric vehicles, things like electric scooters, and as well as disability mobility as well. And of course, boiling all of this together and packaging into a immersive virtual reality environment to really show the environment in a way that normal fly-throughs and still images simply can't. To go over the methodology, it stems much from my experience in animation and game design, wherein the modeling and the overall workflow of a project is slightly different to what you'd expect from an architectural viewpoint. It's different to normal renders in the way that it needs to render frames many times a second, even up to a few hundred a second if your PC is strong enough, which differs from ordinary architectural renders in many ways, because even a still render, a single frame for an architectural model, can take hours, if not even days in some instances, to render. Game engines, while powerful and fast, do have certain requirements, but I believe they make up for these partial negatives with an astounding amount of positives. Optimization is the name of the game when it comes to building games, and in this project that was of course a major consideration that had to be taken. The methodology follows a three-step process: pre-production, production, and post-production, which is fairly standard across many methods, but I'll go into more detail about the games design version of them as well. Pre-production is of course when you before you get into actually building what you're wanting to build, you need to figure out exactly what it is you're going to build. Some early design work, finding, creating, sourcing references to inform the design. It's a process of how to best create what you're wanting to create. Early iteration as well is is where I would place in pre-production, and it's one of the most important steps by far. And generally in our project we wanted this to be done fairly quickly so we could jump straight into production. Production's where the meat of time and effort comes into building anything, especially in a game engine. Modeling, texturing, implementation, and testing is the general flow that you need to have, and you repeat that until it's done. But each one of these has its own workflow that you need. Modeling can be as simple as taking a box and turning it into a building, or taking an already established model and making it more efficient for a game engine process called retopology. Texturing is also, can either be simple or not simple. It can involve 3D sculpting and projecting normals and the details of a building from an extremely high resolution mesh, which can't be used in a game engine, to a low resolution, which can. Most of the time in our project was spent in this phase, where, as you can see, we went through many different iterations and taking things in and out, testing them, seeing if they work, and if they don't, taking them back out, redoing them, bringing them back in, which is a major strength of this workflow, as it's really fast. You can iterate very, very quickly, and if you need to make even significant changes, you can do so very quickly. Which brings us into post-production. Post-production is where things differ a little bit from ordinary projects. Post-production in this particular project involved things like lighting, post-processing, and sound, which ordinarily would take place in the production phase. However, post-production for this methodology takes place here. This is also where you do a lot of your play testing as well, or sending them out for alpha and beta testers. It's also where a lot of the more visual high fidelity comes in. It's at this point that you would also package the build to be exported and given to anyone that requires it. The main differences of this particular workflow when compared to another modeling workflow is interaction, iteration speed, the flexibility of the engine, its ability to render in real time, and most notably is its ability to show anything you build in many different ways. You could have the same environment shown on a computer screen, through a VR headset, or even on your phone, if you so chose, which I believe is the true power of this workflow, is just its flexibility and how many things you can build from simple working blocks. As an example of a more traditional workflow, these buildings are built in Navisworks. These are the buildings that I was given and had to rework into more workable buildings. These buildings themselves are constructed of millions upon millions of polygons, which an engine such as Unity or another game engine, for example, such as Unreal Engine, simply cannot run. However, many of the same established blocks can still be used. Taking these buildings and effectively rebuilding them allows you to have a lot more power and control over a lot of the things you don't need to show, which is a lot easier to build and is a lot easier on the designer as well, because if you don't need it and it never shows, then unlike an architectural visualization where every screw, every chair, every light fixture is important, not so much in ours. And it's this power that I believe is very powerful for any kind of quick iterative visualization project. The results of our project came about into a walkable VR environment. You can move around, interact with objects. It has a good amount of visual fidelity, and as it's so flexible, it's extremely easy to make changes to. If I don't like the color of something, I can change it. If I want to make something slightly bigger or move it, I can do that without having to re-render anything. And I do believe it's a good test of the production method. It requires a bit of refinement, as it's still very much in its early stages, but I do believe it is a good result to have. It's a little rough around the edges, but I believe it's a good example of what can be done. Let's go on to my conclusion. It's rough but encouraging, very encouraging. It's an excellent proof of concept in my opinion, and while it does provide its own unique challenges, specifically in taking things such as architectural renderings and having to move them into a much lower resolution, much quicker and different workflow while retaining its visual fidelity. I do believe that any cons are outweighed by positives. And early show testing to many different people, such as city councils, have shown much interest, and there are already talks of further projects with this workflow, which we're all very excited for. Which brings us on to the future. This particular workflow, I believe, has a bright future. Any sort of visualization project or anything you could ever want to create could be built using this workflow and is available to almost anyone. That brings me to my acknowledgements. A very special thanks to everyone in the Hive. Their help was instrumental in the creation of this project. I can't thank them enough. A special thanks to all of my supervisors as well, and everyone else who helped on the project. Thank you. Any questions?
Any questions for Scott? Zach in the back.
Yeah, I remember you talking about the painful process of taking an architectural model, getting it to work in a game engine. What was the final, would you say, percentage reduction in polygon count, polygon count? Architectural models to the models that are currently existing in the game engine version?
Of the 4 buildings that I retopologized, the largest in its original form was a building that had, I believe, 33.4 million polygons. That same building in the scene after I have rebuilt it was a total of 7,000 polygons. Although the largest difference was a building that was 30 million polygons, but I reduced it down to below 4,000. You do lose some visual fidelity, but a model in its original form simply would not run in the game engine. I'd be very impressed if it did. But I was able to achieve a massive drop in polygon count. The main reason for that is not necessarily the overall building itself, but everything within it. Architectural models often have separate models and individual objects for everything in a building. Cables, chairs, tables, light fixtures, power outlets, and all of these things contribute. The largest or the most difficult part of using the architectural models wasn't necessarily the polygon itself. It was the number of objects within the overall mesh, which caused a very high amount of latency issues and having to wait between moving and doing things. The models themselves in their original forms would take even upward of an hour to even load into a scene where I could work with them. Not because it was high poly, but because it was having to load thousands and thousands of objects. So while the poly count was an issue, it was not nearly as much of an issue as the object count, which I believe was the largest issue for the overall modeling of the entire environment. But it was educational, and it was fun.
Any other questions from the floor?
See the walkthrough, or
Sorry?
are we going to see the walkthrough?
Yeah, let's load it up right over there.
Demonstration in the back there, but so anyway, that'll be visible during the presentations. Now I understand one difficulty for the project was that it's about a trackless tram, but you didn't actually have or couldn't actually receive a model of a trackless tram. So
yes,
in that case.
A lot of the time we were waiting to hear back from people that said that people we thought had one, people that said that they did have one, but ultimately it came down to a matter of them not being able to give us the model due to privacy issues and such, which is understandable, though a little disheartening. I then took it upon myself to model the tram myself. It's not quite as detailed as I would have liked it to be, but with the time I had left, I think I did all right. I used reference images that I found off of the internet and sources I was provided to remodel the tram as best I could, and then rig and animate it into the scene.
Very good. So,
can I comment?
Yeah, please.
It's not a question. I think what was pretty interesting about this project and what Scott was exposed to is basically the fact that he had to kind of meet the expectations of a team more from different disciplines, because the supervisory team, from different backgrounds. Jonathan was there from design. I'm an architect. With all those architectural details and colors and materials and specifications that an architect expects, and then of course Peter Newman, from transport background, and the rest of the team. So I think it was a pretty interesting kind of collaboration and teamwork, and I hope Scott also enjoyed as much as we did. Of course, this was an initiation of a bigger project where we can take it to different local governments and just improve that. So it's a fantastic start for us, and I would also like to thank HIVE for giving us this opportunity to be able to develop this idea, and of course we'll progress on that further.
Yes. Most welcome. So I think this project had the largest formal plus informal supervisory team. I participated in a couple of the meetings, and there was a lot of people there indicating sort of a very keen interest in this topic. So I think it's actually worth mentioning to Scott what videos you've actually rendered that are the outcomes in some ways. Well, actually, there's two outcomes. There's one's the animated videos, and the other one's virtual reality simulation.
Yes.
And one can be seen interactively, and the other one's just a video to be seen on a screen that can be used in presentations. So do you want to explain a little bit more about those?
Yes, that's another strength of the engine itself, is its ability to provide things in many different mediums. Just the same as you would send a camera track through an ordinary animation software, you can do that through Unity as well. And I used that technology in combination with a timeline and a add-on called Cinemachine, which allows you to control cameras through many different virtual cameras that you can place around the scene and control in any way you wish. I use that to create a animation which can be viewed on any device, as it simply renders out as a MP4 file. And these files can be created in very short periods of time. You can set up a new camera track within a few minutes if that's what you'd like to do. And the VR itself, it all operates very much the same. It's just a different controller, a different set of scripts, and you can go from the very same scene that you saw a video in and jump into VR. Yeah.
Very good. Okay, well, we'll finish things off there, and please join me in thanking Scott for his presentation. Thank you. All right, lucky last presentation of the day is from Joshua Quizera. Please join us. And after Joshua's presentation, we'll have demonstrations, and I'll say a few closing remarks. And actually, I'd like to get a photo of all of the interns that are here as well. So we'll make sure we get a photo in this last batch as well. And so Joshua, where's my little note here? can't separate the pages. Joshua's doing a bachelor's degree in predictive analytics. Master's degree, oops, I knew there was something wrong there. His topic is vulnerability of the rural southwest volunteer workforce, and I'll give you the microphone and I'll let you go. Thank you.
Right. Good afternoon. I want to begin by paying special gratitude to my supervisor, Professor Kirsten, who's here, and she's from the School of Marketing. Mary, PhD students from School of Marketing as well, and Professor Leone, not sure if I pronounced it right, from Griffith University. And to the most kind have supervisors who have worked so hard to make this possible. That's specifically Carly, she helped me a lot. And to the most kind audience like you spend for sparing some time to come and support us as Hive interns. And without further ado, I want to begin by introducing the topic. The title of the topic is as displayed, and I want to give you a bit of background of volunteering. As we all know, volunteering is a special part of Australia's way of life, especially in rural communities where essential services are completely reliant on volunteers. And those essential services include ambulance, fire services, as well as community life activities such as sport clubs, festivals, and other social, cultural events. But in recent times, volunteering organisations are indicating that Australian volunteer workforce is becoming more vulnerable in terms of demand and supply, and in some cases forcing core volunteers to leave the workforce. So in my research project, I looked at the supply of variables, but initially I did some literature review, which gave me some background in the topic. And after doing the literature review, I did some data gathering and did some data cleaning using ArcGIS, RStudio, and I combined variables that research suggested variables that affect volunteering supply, and I put all those variables in one database, and I applied a method of clustering, which is an unsupervised learning approach, and then consulting with Huygens theorem whether the clustering is a good fit. And then if it's not, I'll go through again, look at the variables. Sometimes the variables will have small fluctuation of the mean, and that will be rejected by the algorithm, and then I'll have to go back and clean the data, keep cleaning the data. And if it's a good fit, then I'll also use Power BI to visualize the clusters or the data in general. But like you might be wondering how I managed to figure out how many clusters from that single data table. So I use an approach called elbow method. So you take the number of clusters and you plot it with within group sum of squares, and the turning point gives you the maximum groups you can have in the data table that will represent the variance in the whole data table. And that, as you can see, it's indicating that it's 3 to 4 clusters, and we're interested in extracting like 3 clusters which would define vulnerability, moderate, vulnerable, moderate, vulnerable, and not vulnerable. Sorry. Now we'll move on into Power BI. So this is the volunteer workforce. The first cluster is the purple bubbles. Those are different towns in the rural southwest. And cluster 2 is the green bubbles, and cluster 3 are the red bubbles. So the area of these bubbles is scaled by volunteering rate, so based on so the area of these bubbles is scaled by volunteering rate, where a volunteering rate scales is used as an R in the area formula, and we figured that in cluster 1 is moderately vulnerable. So cluster 1 is the purple bubbles, and cluster 2 is the not vulnerable cluster, which are the green bubbles, and cluster 3 is the vulnerable group, which is those red bubbles. So now I decided to look at the aging spectrum. So we're looking at supply in terms of the aging spectrum. Grouping the aging spectrum will give us a conclusion as to which town has a better volunteer supply in terms of different ages. So in terms of the aging spectrum, the first cluster is not vulnerable, and the second cluster is moderately vulnerable, and the cluster 3 is vulnerable. This is just based on a single variable, which is the aging spectrum. So this leads me to the social perspective. So we're looking at the distribution of schools in the rural southwest, and the research showed that people are more likely to volunteer if they have been socialized into specific roles. And I looked at the youth between 15 and 19, the supply of volunteers in that age range. And that correlates to, sorry, I don't know if there's a laser, but you can see that the more youth volunteers in areas where there's more clusters of schools, where the accessibility of school, where there's an easy accessibility of schools. So I'll just flick back and forward. So this is the supply of 15 to 19-year-old volunteers, and that's a distribution of schools. And that leads us to family structure. The research also suggests that parents with dependent children are more likely to be asked to volunteer compared to childless parents, especially when dependent children reach school age. So I took the age and then split into 3 groups. So that will represent like pre-primary to primary and high school and sort of university and freshman graduate. So I did a regression model, and the regression model indicates that the number of children between, sorry, just one second. So it indicated a relationship between total volunteer supply in the rural southwest. So there's a really good fit between these variables. I'll just quickly give out the stats. So dependent children between the age of 13 and 17 have a better fit, where 80% of the variance in the total supply of volunteers is explained. And the second variable is the age range between 0 and 12. and the last one is 18 to 24. And we'll move on to the socioeconomic of the rural Southwest. I decided to visualize it this way because I had a few variables to visualize at the same time, so it will be pretty messy to visualize it on the map. On a map is like multiple bubbles. So how this network plot works, we have the 3 clusters, the global clusters we created to begin with. So cluster 1, cluster 2, 3, and these clusters add up to the total number of volunteers in the rural Southwest, and it's mapping them to different socioeconomic deciles. So the legend below shows you which, so it shows you like the red ones are the decile of economic resources, and then the second one is education and occupation, and the last one is a summary. So I created a smaller network for the rural Southwest. This one is for the whole entire state. So looking at the research suggests that people who have better access to economic resources are more likely to volunteer, and the findings in the data agrees because 60% of volunteers from the rural Southwest can be mapped to areas or nodes in this map that have easy access to economic resources. So we'll move on to the education and occupation. So the research suggests that people who volunteer are more educated than non-volunteers, but in the rural Southwest it's a completely different trend, because we can, based on that network, we can map about 39% of our volunteers in non-deprived areas, which means that the rest are mapped to like deprived areas. So it's completely different to what this research suggested. And we'll summarize the socioeconomic, or this is how the ABS summarized the rankings. So 37% of the total volunteers in the rural Southwest can be mapped to advantaged areas, and we have 63% of the total volunteers can be mapped to disadvantaged areas. But this is what the data is showing, but the research suggests that areas that are not economically deprived are more likely to supply volunteers, but completely different outcome in the rural Southwest. Now we look at the employment industries. So we can see the dominant employment industries in the rural Southwest on the bar charts. And I also did a regression model, assuming that everyone who provided unpaid disability work also reported the employment industries. So we can see a trend. With admin support services. These people provided more unpaid disability work. And this is based on the fact that people are more comfortable to volunteer in areas where they can sort of like transfer their professional skills. And retail tradies also have a relationship with the supply of volunteers. It comes second in terms of like how much variance explains of the volunteering table, and health follows, and so on and so on. We'll look at these in the demo. And I looked at the employment status. Australian researchers discovered that unemployed people are less likely to volunteer. And as you can see, the purple profile in the bar chart below is showing that and the orange bit shows orange bars are indicating the unemployment rate. So we can see that volunteering rate increases as unemployment rate decreases. I also did a regression model, but this time just focusing on cluster 2 because most of the towns in cluster 2 are spread over in the rural southwest, so it will give us a better representation. And what I discovered is that East Bambley to Glen Aris and Withers Asher, these towns are controlling the trend of this model. So we can see like a negative relationship. We'll see these in the demo, but these towns have have their stories. I was speaking to Carly, and she'll talk to you afterwards about this trend. We'll discuss about it during the demo. But the overall in the southwest, we can see a positive trend. People who are employed part-time are more likely to volunteer than people who are employed full-time, and this agrees with what the researchers originally proposed. But in cluster 2 particularly, it has a different trend. I'll conclude with the supply and demand summary. So this was determined based on the workload increase. So Volunteer WA provided some data on the volunteering vacancies, and we determined the increase of the workload in every town, which thereby determined how much burnout people can experience if some people choose not to take on extra workload. And I also grouped them in different groups to better analyze them. And finally, I took the global clusters that I created, and then this is what I can start creating classes of which ones are actually vulnerable. So originally in cluster 1, we said that it was moderately vulnerable. So we can see that only one town out of the towns that were originally said that they were moderately vulnerable is actually quite vulnerable. And in cluster 2, we have about 3 towns which are completely vulnerable in terms of demand and supply. And in cluster 3, all these towns in terms of supply and demand are okay. And I'll just conclude by noting a few ideas that we can use to improve the definition of demand vulnerability. So if we can gather some data on different types of volunteering roles and define vulnerability in terms of different types of volunteer work, that would give us a better definition of vulnerability, because having a definition that describes a whole that doesn't really capture what vulnerability means. And also identifying if there are peaks and valleys in the supply and demand for volunteers in the rural southwest, that will also be useful. They've done it in the UK, and they've discovered that during summer and winter, people demand and supply is different. So that would be helpful in the rural southwest to see, like during the harvest season and different seasons, the effect they would have on the demand and supply. That's it. I'll also want to acknowledge my supervisor, Kirsten, from School of Marketing, Professor Leone from Griffith, Mary from the School of Marketing, and other colleagues from UWA, and Curtin HIVE for making this possible and sponsoring this project. Thank you.
Are there any
first question again. When people are volunteering, what sort of things are they volunteering for?
That's what we hope to do in the future. If I understand the question correctly, like, are we?
Well, not necessarily why, but what are they doing? Are they at the local footy club, or is it at a local hospital, or what sort of things do people volunteer? What sort of things are counted as the hours or whatever?
That we don't have data on that, but some of the main roles or work that they do is like driving ambulance and helping out in health services. All these services are reliant on volunteer work. Mm-hmm. Yeah.
So is there any kind of measures that could be taken to use or to make like a treatment for the drawbacks of the volunteering results that you discovered? For example, if there's a town that's suffering from lack of volunteering people, for volunteers in teaching or in helping something, so you conclude that you got the data, you know that there's a drawback here, so there's any measures could be taken to improve or solve the situation?
Essentially, that's what they're hoping to do, I believe, to identify which towns are vulnerable. When we're doing the demo, we'll have a look at some of the like 2 towns that the model sort of like put out there. Like I think it was East Bunbury and with this Asher. Yeah. So once a model identifies these towns, like we will actually assess why there's less supply, and then we'll sort of figure what to do from there. So this is more like identifying that's vulnerable, that's not vulnerable, based on the stats. There's no actual stories yet.
So is there any idea of if you have some redundancy in volunteers in a certain town and in a certain sector, so you can ask for help from these volunteers to move to another city which is vulnerable in the sector and so on?
Yeah, in this map here, it shows like different charity organizations, and their size is determined by the amount of workload that they have. So what we essentially want to look at is to approach these charity organizations, and they will give us that sort of information. Say if that charity organizations has more workload, then they can essentially like give us how they're distributing the work, and that will validate our model to better detect vulnerability. Yeah.
Okay, the last question. So, is there any map of those, or what is the incentives for the volunteers, to know why they are volunteering in this particular field or something, so you can figure out why they are?
I'll let my supervisor help out.
wasn't looking at this as part of this project. There's quite a lot of research on volunteer motivation, but the problem we have in the Southwest is there's a finite number of people who are available to volunteer, and there aren't necessarily, it's at capacity, so there aren't necessarily more people available or more time available. So primarily what the option was doing was trying to identify what are the vulnerable communities, and then what are the variables that indicate vulnerability for the community. So, and we're going to present this to volunteers in Australia in a couple of weeks as well. So they're the policy, they're the people who implement policies, training and lobbying state government for funding, those kinds of things to support.
Any other questions? Because Hassan's used all of his 3 questions now. He can't have any more.
I'll ask one.
Oh, good.
So
Because that resets Hassan's 3 questions. He can ask one.
yeah. Well, I know that a lot of the data that we have here is very, I know that it comes from the ABS, but it's all, the rest of it's quite, how would I put it, positive, in that we're looking at the supply and demand of volunteers. I'm just wondering if there were perhaps more areas that
you could look at in the future that might kind of give more of a picture of the kind of social fabric of some of these places? So, for example, things like I don't want to really say the crime rates, for example, that might give you an idea that there's actually something not quite right socially in a particular area, where there's a lot of maybe perhaps misbehaviour and disengaged people that probably the ones that actually need help and support, that then mean there's going to be an extraordinary demand and no supply because they are the population that need help in the first place. So, like, apart from crime rates, do you think there are any other kind of data that might help tell that kind of story?
I believe there will be some. I'm not sure, but I believe that they.
And even things like diet, do people look after themselves? Like, are they working so much and volunteering so much and then they eat terribly and all have heart disease? And I mean, like, that's starting to get a bit abstract, I suppose. But hospitalisation.
Across the day. As I mentioned, all the interns, please stick around. We'll take a group photo in just a few moments.
Are we going to do the demonstration part?
Yes, we are.
Oh,
yes, it's right here. I was just getting to it. So basically now we're running 9 minutes overtime. That's probably because of so many slides actually. Chloe will be on the cylinder. And also we'll put some of her stuff on the dome. Don't miss it on the cylinder because it's in 3D. Scott will be on the wedge with running on the video and also in VR on the Quest 2. And Joshua will be here on the tile display. So have a look and chat with each of the presenters, look at their demonstrations and have a chat with them about their project. So I'll do my closing remarks now. Thank you so much for all of the interns and all of the supervisors and the Hive team for doing such an amazing amount of work over the past, well, it's really 10 weeks because there was a 2-week Christmas break in the middle as well. So over the past 12 weeks, some people worked through the break. So thank you for all of that work. These projects, we like to see them as the start of something even bigger. So I've already chatted with some of the supervisors and they're keen to take it to the next level. Often these projects are used as demonstrators, a little start to something that can be getting quite big, whether it's either a grant application or a demonstration to industry or volunteering WA. Hopefully, and this is our wish, is that it illustrates visualisation in a new area and it has the opportunity to be taken further. So once again, thank you for all attending. Thank you to the HIVE team in particular for running this space and supporting the project so well. Wesley, Carly and Daniel. And look forward to doing it again next year. So if you've got an idea for a project and you're a supervisor, certainly be thinking about that project for the next round, which we'll advertise in sometime around August, September. And if you're one of the interns, promote the scheme to your colleagues and other students that you work and collaborate with. So thanks again. Demonstrations.